Hi and welcome to my course on Excel functions. My name is Quentin and I'll be your instructor for this course. Functions are tools created by Excel to perform a specific task or do a specific calculation. In this course, I will teach you some of the most powerful and popular functions, as well as some other functions that will really simplify things you do on a daily basis. I will take each function, explain it step by step so that you know exactly how to use it and when to use it. This course is for anyone with any level of Excel knowledge. So whether you are a student, use Excel at home, or use it at work, this course will be perfect for you.
In this lesson, I will show you how to use the today and the now functions. You can get the current date with the today function and the current date and time with the now function. So technically, the now function returns the current date and time, but you can format it to see time only. I will show you how to do that. Let's start with today. As with any function, you have to start with equals, today, open bracket, close bracket, and hit enter or return. And as you can see, today is the 10th of January 2023, and that is the date that it would display. To use the now function, you will start with equals, now, open bracket, close bracket, and hit enter or return. Now as you can see, it shows you the full date as well as the time at the moment when you hit enter after inserting your function. So now to change this to time only, you'll see that Excel automatically customized this, change this to a custom format. So we can go down here and change it to hour and minutes. This will give us a 24-hour format. Or if you want to use AM PM, you'll do hour minutes AM PM. You can also include seconds by choosing the hour minute second AM PM or the hour minute second for 24-hour format. I'll just change it back to hour minutes AM PM like that. Now with the today and now functions, these functions are very volatile functions, so it would recalculate every time you reopen the same workbook. It would always take the current date and the current time at the time when you reopen the workbook. So if you want a fixed date, but on that specific day you want to create a fixed date, and when you open your workbook a week or month or whatever later, it must still show that date that it was on when you started. We'll start with date. So this would be a shortcut. You will use on a Windows keyboard the control and semicolon buttons. So control, semicolon, and it shows you the date. You can always just enter the date, but this is just a shortcut. To do the time, you'll do control shift, hold them both in, control shift, and the colon button, and that would give you the time. As you can see, the time is the same and the date is the same. However, these are functions, and this is just a value that's provided by using the shortcut. Thank you, and I will see you in the next lesson. In this lesson, I will show you how to use the year, month, day, and date functions in Microsoft Excel. The year function, the month function, and the day function are functions used to take a specific input or date, has to be a date specifically, apart and show you the year, the month, and the day individually. So basically October would be month number 10, so the value there should be 10, whereas this one is year 1988, 0103, and that should show you year 1988, month 01, day 03, and you will see the results as we carry on with the lesson. Let's start with the year function first. I'll explain the date function when we've completed these 3 year. So to do the year function, we'll do equals year, open brackets, and then you need to tell the function what you want, what date you want to take apart. So we can simply click on our input here, close the brackets, hit return. As you can see, the year is 1993. Let's do the same with the month function. Equals month, select your input, close. Month number 10 and the day. I'm going to do this one in a different way so that you can see that it works in other ways as well. Equal day, open bracket. Now I'm going to type in this exact input. To type something in with the year, month, or day function, you have to open with an apostrophe. So we'll say 22 October 93, close your apostrophe, close your brackets, and hit return. And as you can see, the day is 22. This I've typed in a different format, so as you can see, all 3 of them are in a different format. So let's do the year. Year 1988, 01, 03, month, and day. As you can see, this is basically what the function does. It doesn't matter what format your date is in, as long as it's in a recognizable date format for Excel, these functions would be able to take it apart. Let's just do this one. What I'm going to do, I cannot copy this. If I copy this function to there, it would automatically just stay as 1988 because I gave it an argument to use. So if we were to change this part here and also select the input, it would still give us the same result, but as you can see, all of them are using this input. So now you are able to just drag it down and Excel will use the next row's value in the same column. So year 2018, month August, which is the 8th month, and day the 15th. The date function is used to put years, months, and days, which are in different cells, back together again. So what we can do with the date function is simply say equals date. We'll open our brackets, and as you can see, it asks you for the year, the month, and the day. So our year is 1993, or simply cell D4, semicolon, month, semicolon, day, close the bracket, and it put it back to a date format. Excel will not put it back to the original format. It will always use the standard format, which is year, month, and day as shown here, but you can always change this by simply selecting a different date format, or if you want it the same as this, we will use the custom format, and we will use this one here that's got short date, short month, and short year, and that will be the same. Another way to do the date format, a function, will be to say equals date, open brackets. Now we're going to type this one in, so it's 1988, 1, 3, close the brackets, and hit return. As you can see with the year, month and day functions, when I typed it out, I used apostrophes. With the date function, you don't use apostrophe, you simply just type in the value. And let's just do it for the last one, equals date, close brackets, hit return, and we want to format this one as a long date. You can do it this way, or you can go to custom, we'll do this, but we don't want hyphens there, we want spaces between, we want a long month, and we want a long year, and it gives you the same value. Thank you so much, and I will see you in the next lesson. In this lesson, I will show you how to use the hour, minute, second, and time functions. As you can imagine, it works very similar to the year, month, day, and date function, except this works on time, whereas the other ones works on actual dates. So the hour, minute, and second functions will take a specific time apart, and the time function would put everything back together again. Let's start with hour. So we will just say hour, and we want this input here. Again, I used different inputs. This would be time with AM or PM. This is 24-hour format, and this is a time with seconds included. So hour is 12 hours, minute 45 minutes, and second is 0 seconds, because Excel sees this as 12:45:00, whereas this one here with seconds, it would show the seconds as well. Let's do this one. Hour, as you can see, this is PM, and this would also be PM, but in 24-hour format. Now Excel sees this as hour number 19. I will show you what happens when we put it back to the time. Let's do minute, and let's do second. "19 hours, 0 minutes, and 0 seconds. On this one, for the hour, I will type it out. Hour, again, put your apostrophe, 04:12:27, close apostrophe, close your bracket, 4 hours. Let's do the same for the minute. Minute, 04:12:27, and let's do the same for seconds. 04:12:27, and as you can see, 4 hours, 12 minutes, 27 seconds. Again, different input formats, different methods of applying the function, but it gives you the same result. The time function, like the date function, will put these back together again. So let's start. Time, like with the date, we do not put apostrophe, so let me start by typing it out. So we do not put the apostrophe, we'll just type 12, semicolon, 45, semicolon, 0. Close our brackets. And as you can see, 12:45 PM. For this one, we'll just select the inputs, close our brackets, and now the result will be 7 PM instead of 1900. Let's see. As you can see, there's 7 PM because Excel's standard format for time is AM and PM and not 24-hour, but you can always change this. Let me do a different method. Right click on the cell, format cells, and we want it to show as hours and minutes without the AM and PM, so 24-hour format. The sample already shows what it will display, and that would be the same as that. Now for the last one, time, we'll select them again, and it would show 4:12 AM. To change it back to this, we will use the hour, minutes, and seconds. Let's just add the seconds but still leave AM or PM. And to have it exactly like that, we'll use hour, minute, seconds in 24-hour format, like that. And that concludes this lesson on the hour, minute, second, and time functions. I will see you in the next lesson. In this lesson, I will show you how to use the WORKDAY and NETWORKDAYS functions. To figure out the next working day from one day, if you give Excel the amount of working days to add, we will use the WORKDAY function, whereas the NETWORKDAYS will calculate the number of working days between two dates. For this example, I've created some dummy holidays. You can enter your holidays based on your country or location, and this will be worked out during the function. So let's start with the WORKDAY function. So what we want to achieve is to find the next working day from our start date, which is the 22nd of October 2022, plus 7 working days. What would be the next workday? So we'll start the function with equals workday, open brackets. So what is our start date? Our start date is B4. We'll just simply click on the cell. How many days is it? We'll click on C4, which is 7. And what are our holidays? So I've put our holidays here. I'll show you what you can do to make this easier. For now, I'll just select the range for the holidays. Close your brackets and hit enter. Now Excel puts this in a number format. Let's just change this to a date format, which is the same as what we've used in our inputs. There we go. So as you can see, 7 working days from the 22nd of October, taking into account holidays, would be the 1st of November. Excel would automatically take into account weekends as well. So even though 7 days from 22nd October should actually be the 29th of October, the next working day based on holidays and weekends will be the 1st of November. Let's do the next one. Workday, start date, number of days, and holidays. Hit return, and as you can see here, 16 working days from the 6th of November, taking into account the holidays, would be the 28th of November, even though 16 days from the 6th of November is the 22nd of November. Now to make things easier, instead of selecting the range every time, we'll just give the range a name. So select the 2 holidays. If you've got more, you select the whole range. We'll click in the name box here and we'll call this holidays and hit enter. So let's do the last one using the shortcut created for holidays. Equals workday, start date, number of days, and now we can simply type holidays like that. As you can see, once you've typed it, it automatically highlights your range that has been named. Close our brackets, and there you go. 12 working days from the 27th of October would be the 14th of November. So let's see how the network days function works. This would calculate the number of working days between two dates, also taking into account holidays and public and weekends. So for this one we'll say equal network days, open brackets, start date, end date, and holidays. So whereas this one, the second argument would be the number of days, this is a reverse of it, so you'll use the end date in it. And from the 22nd of October to the 6th of December, there are 32 working days, taking into account both these public holidays as well as weekends. Now we can simply just drag this down to the next one, and let's enter the last one here, equals network days, start date, end date, and we'll highlight it again. It would automatically change it to holidays because you've named the range. And there we go, 24 work days between the 27th of October and the 29th of November. And that concludes this lesson on the workday and network days functions. I will see you in the next lesson. In this lesson, I will show you how to use the weekday and weeknum or the week number functions. To figure out the day of the week from a specific date, Excel provides the weekday function. This would return a value between 1 and 7. You can also select depending on when your week starts. If your week starts on a Sunday or if your week starts on a Monday, it gives you the option to select which format to use. The weeknum function would give you the specific week in the year for a specific date. So let's start with the weekday function. We'll say equals weekday, open our brackets, what is our date, this is our date here, and then our type. So this would be, you'll choose 1 if your week runs Sunday through Saturday, or 2 if your week runs Monday through Sunday. I will choose 2 because our weeks run from Monday, so Monday is our first weekday. 2. And as you can see, it says weekday number 5. This would mean it was on a Friday. So let's do a quick check and see what day of the week the 29th of April was. April 2022, 29th was on a Friday, as you can see here. Let's do the next one, equals weekday, and let's do the last one, so it calculates the day number of the week no matter what format your date is in. All 3 my dates are in a different format, so it still calculates it. If I were to change to say that our week starts on a Sunday, it would now show, because it's a Sunday, Friday would be day number 6 of the week. Let's just change that back. To do the weeknum function, we'll say weeknum. Again, select your date and when does your week begin. Again, our week begins on a Monday, so I select number 2, and 29th of April falls within the 18th week in the year 2022. I'll simply just drag these formulas down so you can see these do make sense. 16th of December would be week 50. There are 52 weeks, so that does make sense, but you can always go and check all of these. Now I will show you a little extra bonus formula to use to convert the weekday into an actual day of the week, so that you can see what the actual day was. So let's just say a day of week. So to do this, I'll show you two methods. We'll incorporate the weekday function with the choose function. So let's start choose, open brackets, then you will start the next function, which is weekday. Open your brackets again. Now the quickest method, because we've already calculated the weekday, we'll simply just click on the result there. We'll close our brackets. We'll put colon. So what is our first value? Our first value is Monday. Our second value is Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And we'll close off our brackets and hit enter. So just put this in the middle. Day number 5 is equal to Friday. If we were to change just one element there, so our week starts on a Sunday, it would show that it's a Saturday, because Saturday in our formula here is number 1, 2, 3, 4, 5, 6. Let's change that back. We'll simply copy this down. Day number 2 is a Tuesday. Now let me show you the method in case you do not have this result already. So again, choose weekday. Now we'll say we'll have to calculate the result first. So you'll select your date and 2, and then the rest of the formula is the same. I'm just going to type it out quickly. If your week was to start on a Sunday, your first value would be Sunday and your last value would be Monday. Then that result there would still show a Friday. Okay, so as you can see, day number 7 in my week is a Sunday. If we were to just overwrite this previous formula, it would still show Sunday. Just undo that. And that is how you will use the weekday and the WEEKNUM functions. Thank you so much. I will see you in the next lesson. In this lesson, I will show you how to use the convert function. The convert function is used to convert specific values from one measurement system to another. So for instance, degrees from Fahrenheit to Celsius, or the other way around, or to convert something from the imperial to metric system, or other way around. Let's start with the first one. I've typed these out in a specific way as this is the acceptable format that the function would use. So to start with the first one, we want to convert 79 degree Fahrenheit to Celsius. So we'll say equal convert, open your brackets. This would be your value. So in this case 79, or just A4. We want to convert it from Fahrenheit. Now you always need to put it in apostrophes like this. And we want to convert it to Celsius. Close our brackets and return. So this gives you 26.111111 degrees Celsius. We can just take away the decimals and it would give us 26 degrees Celsius. The next one would be to convert 44 kilometers to miles. So again, let's do convert. In example, I'll type in 44 instead of selecting cell A5. We want to convert it from kilometers, and we want to convert it to miles. Close our brackets, and that is 27.34. Want to fix let's just put them all in the middle. Apologies for that. In this case, we will convert pounds to kilograms. Although pounds are commonly known as just LB, in the convert function it is known as LBM. LBM, M would be for mass. So equal convert, open, select your value, LBM, and convert that to kilograms. Close our bracket, and that gives us 79.38 kilograms. Next one will be from inches to centimeters. Convert, and there you have it. Next one would be from gallons to liters. And the next one would be from yards to meters. So this would be how you would use the convert function. What I've done now is converted from one measurement system to another measurement system, but you can also convert within the same measurement system. So let's create a new example here. Let's do 1400. We'll use inches, and we'll convert it to yards, which are both in the imperial measurement system. Convert from inches to yards. And there you have it. So convert function can basically be used to convert any value of either a length, a mass, distance, weight, temperature, and much more from either one measurement system to another, or within the same measurement system. Thank you, and I will see you in the next lesson. In this lesson, I will explain a little bit more about the information functions. Excel provides many functions for checking the value in a cell. The result will either be true or false. What we will do here, I've put some inputs on the side here and the function that we would use on top here. So let's start with the isNumber function. Basically what it would do is see if the input is a number. So let's start. Is equals isNumber, and what is our value? It is 150 or A4. Close your brackets and hit enter. As you can see, it says true, 150 is a number. So instead of typing everything down, I will just simply drag the formula down all the way to the bottom. So as you can see, Excel sees a date as a number as well, because in actual fact a date is represented as a number. It sees currency as a number, percentage as a number, and time as a number. The blank block is not a number, a word or text is not a number, an error is not a number, the word false is not a number, and 17 is a number. Let's carry on with if it is text. Is text, and we'll use the same input. So as you can see, 150 is not text. The second method to use instead of dragging everything down would just be to double click on the little block there. And now as you can see, all of these are not text. The word is a text. This is not a text. False is not seen as a text. And the number 17 is not seen as text. Let's carry on with is logical. Equals is logical. Our value here. Hit enter. So this is how Excel views the values. It only views false as a logical value. Let's do the is blank. So as you can see, it shows false because there is something entered into the specific cell. It should only show true in this row here. So block number F9 should be the only one that's true. As you can see here, it says that it's true that block is false, that cell is false. Is an error. This is used to see if something is an error message or if a formula used is an error. So in this case, only G11 should be true. As you can see there, only G11 is true. Is a formula. So it shows here that this is a formula. So why is this a formula? Let's click on it. As you can see there, although it's displayed as an error message, there's an actual formula there. The formula being equals 12 divided by 0. Therefore the error message, as you cannot divide something by 0. Let's add something that would give a result. 1 plus 1 would give you 2. And it shows true that this is also a formula. It would, however, also show true that it's a number. Is odd will show you if the number is odd. Equals is odd. As you can see, it specifically asks for a number. 150 is not odd. Now it shows error messages here, as this is not a number, this is not a number, and this is not a number, whereas dates, percentage, times, currency is seen by Excel as numbers as well. But this date in its number format would not be an odd number. Let's go on to is even. So let's go through this. 150 is an even number. As you can see with the odd, it showed that this date is false, which means it must be even. Same with the time here. It shows that it's not odd, which means it must be even. It would show you the same error messages with regards to words, and it would show the opposite for these two again. In this lesson, we will cover some of Excel's logical functions. We will start with the AND, OR, and NOT function. All three of these functions would give you a result of either false or true. The purpose of the AND function would mean that for a result to be true, whatever argument you put into your function, all of those arguments must be true for it to be true. So let's start with based on input with the number 2. So let's say equals, and we'll say 2 is bigger than 1, which is true, and 2 is bigger than 3. So let's see what result we get. As you can see, we get a result of false, because even though 2 is bigger than 1, it is however not bigger than 3, so your result would be false. Let's do the exact same argument using the OR function. So equals OR, 2 bigger than 1, or 2 bigger than 3. As you can see, it now shows true, because it would use any one of the arguments. If any one of your arguments are true, the result will be true. In this case, 2 is bigger than 1. Not. Let's see what the not function does. So let's say 2 is equal to 2. We know that 2 is equal to 2. That is why the not function shows false, because in this case it says that 2 is not equal to 2, which is false. Let's carry on to the next one. And let's say 4, we'll type it in this time, is smaller than 9, and 4 is bigger than 3. As you can see, it shows true. 4 is smaller than 9, and it is bigger than 3. Let's do OR. OR 4 bigger than 9, 4 smaller than 1. So are any of these arguments true? Let's see. None of them are true. Equals not. 4 equals 5. As you can see, now it shows true, because 4 is not equal to 5. I'm just going to copy these same exact values and paste them there. So let's see the results here. In this case, it would take 3, the argument of 3. Is 3 bigger than 1? Yes. But is 3 bigger than 3? No. 3 is equal to 3. So that is why you get a false. Let's just take this one here. Is 7 larger than 1? Yes. Is 7 larger than 3? Yes. So both of these arguments are true, but for the OR function, only one needs to be true for your result to be true. In this lesson, I will show you a bit more about the if as well as the if-s functions. The if function is one of the most widely used functions in Excel. We will start with the if function, and then I will do the if function and the if-s function in the bottom table here. So these are simple scores by students, and this would tell us if they've passed or if they failed. The passing score is 55. So let's start with the if function. So the if function, you'll give it an argument. It will give you a result if that argument is true, and another result if that argument is false. So what is the logical test here? We want to see if this score is higher than or equal to 55, or we'll just click on 55. Okay, value if true, we want it to say that the student has passed. Value if false, we want it to say that the student has failed. And we'll close our argument, and as you can see, this one has passed because 59 is higher than 55. Let me type this one out. Equals if, we'll say 92 is greater than or equal to 55. If true, we want it to say pass. If false, we want it to say fail. Close our brackets and enter. So let's do the next one. If 49 is greater or equal to 55, value if true would be pass. Value if false would be fail. And as you can see, this student failed because 49 is lower than 55. I will simply just drag this one down. So this one is a pass, although the student got the exact score, because 55 is the passing score, and this is why we said greater than or equal to 55, which means anything from 55 and above will be a pass. In this table below, I will explain the if function again, and then also explain the if-s function to show you when the if-s function is a better function to use, as your formula would be a lot shorter to get the same result. So let's do the if function in the first column here. So we'll start with if the student score is less than 60, the result would be an F. Now, to nest the if function, we need to create another if function for the false value. So if the student score is less than 70, their grade would be a D. If the student score is less than 80, the grade would be a C. If the student score is less than 90, the grade would be a B. And lastly, if the student score is greater than or equal to 90, the grade would be an A. Now with the if function or any formula typed in Excel, all the brackets that you've opened you need to close again. So as you close a bracket, it would show you which bracket you are closing. So let's start. That's 1, 2, 3, 4, 5 brackets. And as you can see, the result here is a grade of F because it is less than 60. I'm simply gonna drag this formula down. This one is 92, which is higher than 90, it's an A. 49 is also less than 60, so it's an F, and this is 72. If we were to change this result to, say, 68, it would change it to a D, because it is higher than 60 but less than 70. So now let's look at the IFS function and see why it is a better function to use in this case. So we'll say IFS, if the student score is less than 60, their result would be F. Now, the difference is that you don't have to type the whole IFS again. You can just put the next argument. So if the score is less than 70, the result would be D. If the score is less than 80, the result would be C. If the score is less than 90, the result would be B. And if the score is greater or equal, if the score is greater or equal to 90, the result would be an A. So instead of nesting a whole lot of ifs, we just simply list all the arguments, we open the bracket once, we close it once, and we'll copy this formula down. And as you can see, it gives us the exact same results, but with a formula that is a lot shorter than using the if function. So that concludes this video on the if and the ifs functions, and I will see you in the next lesson. In this lesson, I will show you how you can use the if error function before typing out your formula to see if your formula has an error in, so that it doesn't show you an error message. Before I do that, let me just create some error messages here. So as you can see, I've put 5 and I've put 2, but I've used 2 as in the word and not a number format. So if we were to say equals 5, or the cell reference divided by the next cell reference, which I've written as 2, it would give us an error message showing that there is a value missing. If we were to do 198 divided by 0, remember you cannot divide by 0, it would show you an error message, division by 0. If we were to add the two of these together, but we want to use the sum function, and we type it wrong, so we type sum like that instead of SUM, we type it as SOME. 4 or B5 plus C5 or 5, it would give us an error. So the if error function can be used in conjunction with your normal formula to show you if the result would be an error. If it's not an error, it would give you the result of your normal formula. So we'll start with if error, open your brackets. Then we'll do the same formula. We'll say 5 divided by 2. And if it's an error, what do you want Excel to display? We can just say formula error. And as you can see there, it says that there's a formula error there. Let's do the same with this one. Equals if error. Now we'll do our actual formula, which is 198 divided by 0. Formula error. And it shows you there's a formula error, and we'll do the same with this one. If error. Now we're going to nest our sum, which is wrong. into the IFERROR function. Sorry. Okay, so it shows you that there are formula errors. So let's correct this. If we change that to 2 in its number format, as you can see, your normal result for the formula and your IFERROR formula will give you the same result. But by applying the IFERROR formula and telling Excel to tell you that there's a formula error, it would show that there's a formula error instead of the error message. Let's change this to 1, and as you can see, 198 divided by 1 is 198, and the IFERROR function gives you the same value. And now let's change this one to sum the correct way. As you can see there, 9, and if we change this to sum spelled the correct way, it would also show you 9. So just a simple function to apply before actual formulas to show you a specific message instead of an error message from Excel. That concludes this lesson, and I will see you in the next lesson. In this lesson, I will show you how you can use the VLOOKUP and HLOOKUP functions. Excel offers a number of functions to look up and retrieve data, but the most popular ones are definitely the VLOOKUP and HLOOKUP. VLOOKUP basically means that it looks for a specific data in a vertical range or table, whereas the HLOOKUP does it horizontally. So I've created the exact same input table for us with our information table, one as vertical and one as horizontal, just to explain both of these functions. So what we want to do here, we've got some employees, we've got their monthly sales, and we want to see what their commission is based on a predefined commission structure. So under $50,000, or I'll just put it as 0, they don't get commission. 50,000, 3%. So basically from 50 to 74,999 will be 3%, and so on. Above 150 will be 6%. So to work this out, we'll start in this one with the VLOOKUP, because our information goes down the columns vertical and not across the rows or horizontal. So let's start. VLOOKUP will say equals VLOOKUP. We'll open our brackets. The lookup value, what is it that we want to look for? We want to look for where the employee sales falls in the commission bracket. So this will be our lookup value. Where are we looking for this value? We are looking for it in this range here. So you'll simply select the whole range like that. That is our range. What do you want to display? Which column index number? So which column in the range is it? That's column 1, this is column 2. So we'll say 2. And the match, do you want it to be an exact match? We can't have it as an exact match. Otherwise it would not show a result unless the employee sales is exactly one of these. So we'll just say true, which is an approximate match, and hit return. So as you can see, this employee with 129,445 sales for the month will get 5%, which is between 100 and 150,000. So that is correct. I've made this specific one as a percentage format. The next one is just general format. So I'll just show you how it would display the result if you don't make it a percentage. So let's do again. VLOOKUP. Want to look for this value. Where do we want to find this value in this range or table? We're looking at column number 2 and an approximate match. So as you can see, it shows it now as 0.04, which is in essence 4%. But all we can do, we'll just select all of these, and you can either click there to make it percent, which is the quick way to do it, or we can go through the number formats and select percentage from there. But we'll just do it this way. Now let's do the next one. VLOOKUP. So you can see here, this employee gets 0% because his sales was not 50,000 or above. If we were to change that to exactly 50,000, it would be 3%. And let's do the next one. This one, because it's over 150, you will get 6%. As you can see here, this is between 50 and 75,000, so it falls as 3%. I'm going to just quickly do something and show you another trick in Excel. If we were to drag these down, just to copy the formula, let's see what happens here. It shows that that one is 4%, that one is 3%, that one is 5%. If we were to drag it down all the way, these are correct. If we were to drag it down all the way from the top, it would start giving us error messages. So why is that? What does Excel do? Excel moves your formula down to the next value, which is correct. We wanted to look at the next value, C4, but it would also move the whole range down one. So whereas this range started at G2 and ended at H7, when you move it down, it moves it down to G3 and H8. So to prevent this from happening, we need to lock this specific range. To do this, we will put a $ in front of the G and in front of the 2, because we want to lock that whole block, that whole cell, and we'll put a $ in front of the H and in front of the 7. If you only want to lock a column, you'll only do it before the column letter. If you only want to lock a row, you'll only do it before the row number. So now this range is locked, but our value to look up is not locked because we need that one to move down. So let's hit enter and see what happens here. And now you can see that it works it out correctly. Now to work out the total commission, we'll take the sales times by the commission percentage. This we can simply just drag down. So you can see here the one with 0% does not get any commission. So to do the HLOOKUP, it works exactly the same as VLOOKUP, but where it asks for a column index, you will just put a row index and it works across and not down. So we'll say HLOOKUP, open brackets. What do we want to look up? This. Where do we want to look for it? We want to look for it there. The row index, it's row number 2, and true. Again, change it to percentage. Let's just put it in the middle so it looks the same as the top. And there, it's 5%, 5%. I'm just simply going to enter this in already. So let's see what happens if we decide we don't want to lock our formulas like I've shown you there. We just want to give this a name. So let's just call this HLOOKUP. Select your range, go to the name box, give your range a name, and hit return. So let's see, HLOOKUP, open brackets, what do we want to look for? Where do we want to look for it? We want to look for it in HLOOKUP. Row index is number 2 and true. 4%. Now let's see if this works. As you can see, two methods of locking a specific range. One would be to name the range. The second method would be to lock the start and end points of your range. Simply double click there and you can see the results works exactly the same for the H and V lookups. The only difference is your information table, whether it's vertical or arranged in columns or horizontal or arranged in rows. And that concludes this video for the H and V lookup functions. I will see you in the next lesson. In this lesson, I will explain how you can use the index and the match functions in Excel. These are also lookup functions, but the index function is a lot more powerful as you can use it as a V or an H lookup. So it combines the two. As you can see here, I've created quite a large table with just some monthly commissions earned by employees throughout the year, and we want to create a formula where we can see how much a specific employee earned in a specific month. So I've just entered employee 7 for March. So as we can see, employee 7 in March earned 985, but that is the result we would want our formula to give us. So I'll do the index function alone first, and then I'll incorporate the match function as a nested function inside the index to make things a bit easier. It's a longer function, longer formula, but it would make the calculations much easier. So let's start with index only. So we'll say in equals index. So where do we want to look for? We want to look in this table here. What row number do we want to look for? So in this case, employee 7 would be row number 1, 2, 3, 4, 5, 6, 7, 8. Row number 8. What column number? 1, 2, 3, 4. Column number 4. And we'll close it. As you can see there, 985, which is employee 7 for the month of March. Unfortunately, if you only use this and you change this to employee, let's say employee 8 for April, it won't change anything because the function as index only looks for the intersection of row number 8 and column number 4 in a specific table. So this is where the match function comes in handy. So we'll restart this now. We'll find employee 8's commission in April, which would give us a result of 1483. So let's redo this whole formula. I'll explain as I'm doing the formula what it is doing. So index, this starts the same. We still want to look in this table here. Now our row number. We will use the match function to find our row number. So we'll say match. What do we want to look for? We want to look for employee names, which is down the rows. So we want to find employee 8. Where do we want to find it? We want to find it, that would be row number 1, that would be the last row. So basically it's going to find the position of the input or employee 8 in the rows here. And what match do we want? We need an exact match. We close this. Now we've used the match function to find our row number. We'll use the match function to find our column number as well. So semicolon match. What are we looking for? We're looking for the month. So the month there. Where do we want to find this month? We want to find it in columns starting with the first column and ending with the last column. And we want an exact match. Close our brackets there. Close our brackets there. And hit return. And if it works out, the result will be 1483. And as you can see there, 1483. So now we can search for employee 5, which would be 1126. Now I'm going to just add a little trick in case you make a spelling mistake. So let's see employee 5 like this. We forgot to put a space. Now it shows us an error. So to fix this, we'll do a little drop down in the cell here. We'll select the cell. We'll go to data. We'll click on the data validation here. You'll make this a list. And your source, which means will be your list. We will create the list here and say, okay, now you can never make a mistake. You can simply just select which employee it is, and you can type the month that you want to find the commission for that specific employee. So employee 5 in the month of July was 1472, 1472. And this is how you can use the index and the match function to find values at intersection of rows and columns in larger tables. Thank you so much, and I will see you in the next lesson. In this lesson, I will show you what the row, column, and the rows and columns functions are and what they do. So we'll start with the row function. The row function would tell you at which row a specific reference that can be a range or it can be a specific cell is in your sheet, whereas the column function would show you the column number, which might be helpful. As you can see, columns are lettered, rows are numbers. So the row function might not be something that you would use, but let me explain all the ways you can use it, and then you can always decide if you need to use this. So let's start with the row function. Firstly, let's just get the row for the current cell that is active. So to do that, we'll just say row, open bracket, close bracket. Okay, and that shows that we are in row number 3, which we already know because we can see it there. Now, to get a specific row number for a reference or a specific cell, we'll say row, and we want to get the row number for that cell there. Okay, that is in row number 10, it's in row number 10, so that is correct. You can also use the row function to get row numbers for a specific table or range. So let's do a range first, row, and let's just say range from there without the first one. And now see what it will do here. It would show you that this range is in row number 2, 3, or from row 2 to row 11, which is correct, 2 to 11. Okay, we can remove that. And now if we were to ask it what rows this entire table is, it would still just show us up to 11. So it doesn't do anything with columns, just shows us that the table starts at row number 1 and ends at row number 11. You can also type in a specific cell reference. So let's just say row, we want the row of PQ4975 and 4875, apologies. And as you can see, the row number would be row number 4875. Let's carry on with the column function. So we'll say column, current column is column number 9. So we can just count quickly, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is column 9. Okay, column of that cell there is in column number 6. And then let's just do column of the whole little table here, and it says that it's in column 4, 5, 6, and 7. And then we can just say row again for the entire table. So then it would basically tell us that this table here starts at row 1 to row 11, and it starts at column 4 to column number 7. So that is our entire table range, basically in simple column and row number formats. So let's move on to rows and columns. So what is the difference apart from the S at the end? The rows and columns with the S at the end can also be sum, as it counts the number of rows and the number of columns in a specific range or table. So we'll just use the same table. So let's see how many rows are in this table. So as you can see, it asks you for an array, which is a range. So you have to select a specific range. So rows, columns. So this table consists of 11 rows. Let's do columns. And 4 columns. To make it easier, we can always just call this table, whatever you want to call it, and we'll say rows, and we'll just say table there. Columns of table, 11 rows and 4 columns. And then we can also just say we want to know how many rows are from this cell to that cell. Now, as you can see in the bottom here, it says that I've selected 27 rows and 1 column. So the answer should actually be 27. And as you can see there, 27. Let's do the same with columns, but we'll just select a larger range. In the corner again, 13R, 13 rows and 11 columns, but we'll let the function give us the answer, 11 columns. So that concludes this video on the row and column functions, as well as the rows or row S and columns or column S functions. Thank you, and I will see you in the next lesson. In this lesson, I'm going to show you how you can use the hyperlink function. You can use the hyperlink function to construct a link with a formula. Also note that the hyperlink function lets you build both external links and internal links. So you can navigate to external sources, which can be a website or a different file or workbook in this case, or internally within your current workbook. So to create, we'll first need to create some targets for the hyperlink. So where is it going to take us? So let's start with Google. Note that I typed the whole link, not just www. It requires you to put the HTTPS in front. So that would be for Google. Now Excel is going to create a hyperlink in this. We can just simply hover there and undo it, because that is the purpose of our hyperlink, is to do this. To navigate to a sheet, you'll say hashtag. You'll say what sheet it is. We want to go to sheet 5. It has to be the sheet name. So if sheet 5 was named something else, you need to use that exact name. So sheet 5, and where do we want to go? We want to go to the first cell, which is A1. Hit return, and then a test workbook. I've created a workbook here just called test.xlsx, and that is where we want to go. We want to go to test.xlsx. Now on this, I will just show you why it would work this way, and then show you what you can do if it doesn't work. My current book, book 2, is saved on the desktop, so in the same folder as this test document, and I will get back to that later on in this lesson. So let's start with the hyperlink formula. We'll say equals hyperlink, open brackets, the link location. So where is this link located that you want the hyperlink to take you to? It's located google.com. In this case, we'll just use the cell reference, and you can give it a name. We'll call this one Google. You can call it anything you want, but I'll just use the name as the name for the hyperlink. So let's see what happens. It gives us a hyperlink that should be linked to google.com with a name of Google that we've decided on. So if we click on this, let's see what happens. As you can see, it takes us to google.com. The next one would be to navigate in a sheet. We'll do it exactly the same. We'll say hyperlink, open brackets, the link location, that is our link location, and we'll just call this new sheet to go to. You can call it anything you want. And there we go. As you can see, new sheet to go to. If we were to change that last part to P5, it would be sheet 5. Just undo there. So when we click on this, it should take us to sheet number 5, cell number A1 in the same worksheet. And there we go, sheet 5, A1. Let's see what happens if we change this to another column. Let's call it column PS and row number 47,658, for instance. And where does it take us? It takes us to column PS, row 47,658. The next thing would be to navigate to a specific document. In this case, document test.xlsx. So again, hyperlink, open brackets, we want to go there, and we'll just call it the test workbook. Close brackets. So let's open it, and it opens the test workbook. Now I'm going to take this test workbook and I'm going to move it into that folder. So it's not in the same folder as our workbook that we're working on anymore. So let's see what happens now. Now it says that it cannot open the specified file. So in a case like this, you'll need to give the function the full link address. So a file also has a link. That's why you can navigate to it. This would be the link for the specific sheet and cell number. This file also has its own link. So let's go to this file here. We'll say properties, and this is the link location. So we can just simply copy that. Let's close everything up here. And we'll add that in front of it with a backslash. So it would take us to drive C, folder users, Quentin, desktop, test folders, to that file. So let's see if it works now. And there we go, it opens it again. So that is how you can use the hyperlink. Just to show you that you do not need to have the specific value here. You can give the hyperlink the value in the formula itself. So let's just remove that part there. We'll put in apostrophes, https www.google.com, close it, and it would take us to Google without having to use a specific target, and you can do the same with each one of the other ones. That concludes this lesson on the hyperlink function. I will see you in the next lesson. In this lesson, I will show you how you can use the transpose function. Transpose is an easy way to convert data from vertical, as it is here, to horizontal, or from horizontal back to vertical. So what I've done here is just created a little table, months of the year, how many days are in there, and how many holidays, which are just some random numbers. It doesn't pertain to anything specific. So to use the transpose function, we want this, we've created a table like this, but we want month, days, and holidays to be down, and our results to be across, horizontal, for instance. So change it from a vertical table to an horizontal table. So let's start. We'll say equals transpose, open brackets, and what do you want to transpose? We want to transpose this whole thing. Again, as explained in previous lessons, you can always give this range a name there and just enter that name instead of selecting it like this. You can also say B4 to D16 colon D16. Okay, so once you've selected your table or your range you want to transpose, close your brackets, simply hit return, and there you go. It's now placed in a horizontal table and not a vertical one. The main important thing to remember about a transpose function is that it's a dynamic function. So if we were to change, say, the holidays in June from 2 to 9, once we do that, it would also change in this table here. If we were to delete this table, everything here would also be deleted. Let's just undo. So there is another way that if you've created a table that is in one format, vertical or horizontal, and you want to change it to the opposite, you can simply do a one-time operation, which is selecting it, right-click copy, click on the cell or right-click immediately in the cell where you want to start your table, right-click again, and this paste option would be transpose, or you can say paste special and find transpose there. So either way, this would now give us a one-time operation. If we were to delete this, it would affect the dynamic function, but it won't do anything to the one-time operation. And if we were to change the holidays back to 2 year, you'll see that it only changes there. It doesn't change here. So that is how you can use the transpose function to move data to move vertical data to horizontal data and vice versa. Thank you. I will see you in the next lesson. In this lesson, I will show you how you can use the COUNTA, and the COUNTBLANKS function to count values in cells. This works differently to the SUM function, where the SUM function would add the values, providing you with a sum. The count function would basically just give you the number of cells containing data in a specific range. The count function only counts numbers, so anything that's in a number format, whether that's a number, currency, a date, or a percentage, it would count anything that is seen as a number in any of its format. So let's start here. Equals count, and we'll just select our range. Close our brackets. As you can see, there are 5 numbers because we are using the count function here. Let's copy this formula down. In this range there are 0 numbers, that's why it provides us with an answer of 0. This one is 4 because this cell, even though it's a cell there, it is blank, so it doesn't count it. This one, there's 1 blank cell and 2 letters, 2 texts, so only those 2 are seen as numbers, giving us 2, and 1, 2, 3 percentages, giving us 3. The COUNTA function will count anything, numbers or text, but it will not count blanks. So if you want to just count how much data is in a specific range, how many cells contain data, and it's a mixture of numbers and text, you would use the COUNTA function. So exactly the same, COUNTA, open bracket, select your range, close your bracket, hit return. So again, it shows you that 5 cells contains either numbers or text in that range. Let's see here, 1, 2, 3, 4, 5. This one only 4. Again, the same result as the numbers. It counts it whether it's a number or text. In this one, however, it counts 4. It counts the text and the numbers and the dates, everything that's mixed, as long as there's data inside the cell. And this one also 4, where the count one only counted the 3 numbers. Blanks would basically count the blanks in a specific range. So the function for this is COUNTBLANK, open brackets, select your range, close your brackets, hit return. There are no blanks here. There are no blanks here. Oh, there's 1 blank in this range here. Let's draw it all the way down. 1 blank in this range here, 1 blank here. If we were to remove just one of these, you'll see that the COUNTA goes down to 4 and it shows that there's a blank. Remove another one, becomes 3 and 2, and so on. So that concludes this lesson on the COUNTA, and COUNTBLANKS functions. Thank you, and I will see you in the next lesson. In our previous lesson, I showed you how to use the count, COUNTA, and COUNTBLANK functions. Those functions are used to count the number of cells containing specific data. Count would count the number of cells containing numbers. COUNTA would count the number of cells containing anything in it, whether it's text or numbers, and COUNTBLANK would count the number of empty cells in a specific range. In this lesson, I'll show you how to use the COUNTIF and COUNTIFS functions. These functions are used to count cells containing data based on specific conditions. The COUNTIF function, you can only apply one criteria, where the COUNTIFS function can apply multiple criteria at the same time. I've purposely created this column here. So we've got a little table here with bicycle sales that we've done in the month of November. There's dates here and color of bicycle and country where these bicycles were sold. So this is the quantity sold, but I put it here so that you can see why the count functions would not work to give you the quantity that you've sold. I'll explain as we carry on through the lesson. So let's start with the COUNTIF function. So what we'll do, we'll count the number of cells in this range here that contains the word red. So that is basically all this function would do for us. You give it the criteria and it counts cells matching that criteria. So to apply this function, we'll say equals COUNTIF, open your brackets. The range that you want to count in would be this range here, semicolon, the criteria we are looking for the word red in apostrophes like that. Close your bracket, hit return, and it shows you that there are 3 cells in this range with the word red in it. So that would be 1, 2, 3. Let's do the same on the column next to it. We'll say equals COUNTIF, range, just simply click on the first one, drag it down to the last one, release your mouse button. Criteria, we are looking for Canada, close our brackets, and there are 4 cells, 1, 2, 3, 4, that contain the word Canada in it. Now the COUNTIF function cannot search for 2 criteria at once. So we will use the COUNTIFS function to apply multiple criteria. To do that, we'll say equals COUNTIFS, open our bracket. So it's asking us for criteria range 1. So let's just use this as our criteria range 1. We'll look for blue first. And what is the criteria? We are looking for blue. So far it's exactly the same as the COUNTIF function, but we can now just put a semicolon and then add a second criteria. So our second criteria range would be the countries, semicolon, and we're looking for USA. And that is it. We've only got 2 criteria here. You can carry on with quite a number of criteria depending on what you want to use this function for. Close our brackets and hit return or enter. So it would find blue and USA. So there's only, there's 2. The formula actually shows 2. So it would be those 2. So it's blue and USA, blue and USA. As you can see, there's no other criteria that has blue and USA in the same line. Now, Australia after the 15th of November. So how many cells would contain Australia after the 15th of November? So let's see how we will apply this function. We'll say equals COUNTIFS, open your brackets. Range 1, we'll use this range here, and we'll say Australia. So the function will start looking for Australia. Once it found all the Australias, 1, 2, 3, 4 of them, it would apply the next criteria. So criteria range 2 would be our dates, and what is our condition here? We want it to be after the 15th of November. So in order to do that, we'll use the greater as formula. We also put it in apostrophes like this. So we'll say greater than 15 November 22, close the apostrophes, close our brackets, and hit return. And it shows us that after the 15th, so it excludes all of those, after the 15th, there are 2 Australias in this criteria range. And there you have it, 1, 2. Now, we cannot use the count function to add values together. So say we want to now find out how many bicycles we've sold. The count or COUNTIF or any count function does not perform that function. The function of count functions is to count cells, individual cells, not to count numbers inside a cell together. We use the sum function for that, and I will explain a bit more about the SUMIF and SUMIFS functions in the next lesson, but I will just show you quickly if we were to use the count function to count all those up, it would give us 12. Basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cells that contains numbers in it. It would give us the exact same answer for COUNTA function, and I will also now show you how you can use the COUNTIF function to perform the same function as the COUNTBLANK. So let's remove a couple of data from the cells there. As you can see now, the count has gone to 8. So what we will do is we will now use the count. I'm going to do the COUNTBLANK function first. So we'll say equals COUNTBLANK. We've already done this in the previous lesson, but I want to show you how you can use the COUNTIF function to perform the same calculation. So let's do it with COUNTIF. COUNTIF, our range, and what is our criteria that we want it to do? We want to say there is no data. So to say no data, we simply put 2 apostrophes to say that there is no data. Apologies, I wasn't supposed to put a space between them. Just 2 apostrophes next to each other, and it does the exact same thing. So COUNTBLANK function can also be replaced with the COUNTIF function. That is why it's a bit more powerful than the COUNTBLANK function. Thank you so much, and I will see you in the next lesson where we will explore the sum functions to actually add values together. In this lesson, I will show you how you can use the SUM, SUMIF, and SUMIFS functions. The SUM function would be used when you just want to get a total in a range to sum up the total, whereas the SUMIF and SUMIFS functions are conditional formats where certain criteria has to be met in order for it to do the calculation. SUMIF function you can only give one condition to, whereas the SUMIFS you can give multiple conditions to. So let's first start here. We want to just work out the total. So let me just do a normal formula so that we see what the total is here. This would be the long way to do it, just adding all the totals together. So the total sales on bicycles in month of November was $14,450. Let's do the same but with the sum function. So we'll say equals sum, open your brackets, select your range, close your brackets, hit return. And as you can see, 14,450. Now we want to work out how many red bicycles we've sold in November. So to do that, we'll use the SUMIF function. You can also use the SUMIFS function, but I will just show you the SUMIF for single criteria and SUMIFS for sums where there are more than one criteria. So we'll say equals SUMIF. What is the range that we want to find our criteria in? It is this range here. That is where the colors are. What is the criteria? It needs to be red. And where is our sum range? Our sum range is this one here. Close our brackets, and red bicycles sold for the month of November came to a total of $3,400. How many bicycles did we sell in Canada? Let's work out using the SUMIF function again. SUMIF. Our range would now be this range here. Our criteria has to be Canada, and our sum range is again this one here. Close your brackets. So red and Canada comes to the same. Let's just double check that quickly. So we've got 1, 2, 3, 4. These are all the ones sold to Canada. What I've done now is just simply hold down my control button and clicked on each one. And as you can see, the sum at the bottom here would be 3,400. Red ones, 3,400. If we were to change this to green, for instance, let's just change that to green. It will be 4,250 on green bicycles sold. Now we want to calculate how many blue bicycles were sold in the USA. So the conditions need to be blue and USA. In this one we will use the SUMIFS. SUMIFS. For the SUMIFS, you give your sum range first. It works on one sum range with different criteria. So let's select our sum range. Our criteria range, we can do any one of them first, but I'll just do blue first. Criteria range is that, and it needs to be blue. Then our criteria range 2 would be that one there, which is the countries, and it needs to be USA. Close your brackets, hit return. So blue bicycles sold in the USA in November came to a total of 2,975. We can quickly check that. Let's just see blue and USA. There's one there, blue and USA, and nothing further. As you can see, the sum is 2,975. Now, how many bicycles did we sell in Australia before the 16th of November? So I'm going to highlight them already. It would be that one and that one. So our calculation needs to come to a total of 2,125. Let's do this also using the SUMIFS function. SUMIFS. Again, sum range stays the same. Our first criteria is that the country needs to be Australia. Our second criteria is that the date. Now this is very important how this is typed in. So that is our date range. It needs to be, you still put it, even if it's basically a formula that we're going to type now, you still put it in the apostrophes. So it needs to be smaller than 16 November 22. I'm just typing it. You can type it in any date format, but I'll just use this one as this is the format that we've used here. We close our apostrophe, close our brackets, and hit return. So 2125, and that was what we had for Australia before the 16th of November. And that is how you can use the sum, SUMIF, and SUMIFS functions to perform standard calculations or calculations based on conditions and specific criteria. Thank you, and I will see you in the next lesson. In this lesson, I will show you how to use the average, AVERAGEIF, and AVERAGEIFS functions. They basically work exactly the same as the sum, SUMIF, and SUMIFS functions, except that it would work out an average. So add the total together divided by how many items are in the range. So I've created two tables for a specific reason, because if we want to work out the average sales for the week, using a table as above would not work it out correctly, because the working week only has 5 days where there are 10 elements in the table above. So what I've done is I've used the SUMIF function that you learned about in the previous lesson to get the totals for Monday, Tuesday, Wednesday, Thursday, and Friday. I will just show you what the normal average function would do based on the table above. So we'll say equals average. You simply select your range like you would with sum, and it would tell you that the average sales is 1105, but that is based on 10 elements. Let's do the correct one from the bottom table. Average okay, so the average sales per day is 2210. To work this out using a normal formula, we can simply say sum of that divided by 5 days, and you'll see that it gives you the average, which is exactly what the average function does, just a little bit quicker. To work out the average sales on blue bicycles, we will use the AVERAGEIF function as follows: equals AVERAGEIF. The range where we want to find our criteria would be this range here. What is the criteria? Needs to be blue. And what is the average range? Average range is that one there. So the average sales for the week on blue bicycles was $956.25. If we want to work out average sales on green bicycles on a Friday, let's work that out using the AVERAGEIFS function. Equals AVERAGEIFS. Same with the SUMIFS function, you give it the range that it needs to calculate from first, so which would be this range with the totals here. What is the first criteria? So our first criteria range, you can select either the colors or the days of the week. It would still work out the same, but let's do the colors, and it needs to be green. Second criteria range would be the days of the week, and it needs to be a Friday. Once completed, close your brackets, and there we go. The average sales on green bicycles on Friday was $1,487.50. And that concludes this video on the average, AVERAGEIF, and AVERAGEIFS functions. Thank you, and I will see you in the next lesson. In this lesson, I will show you how you can use the min, max, large, and small functions to calculate minimum, maximum, and largest, smallest, and in between numbers in a specific range. So we've just got some students and scores that they've achieved here, and we want to work out specific results based on these scores. So we'll start with the min or the minimum function, which would calculate the minimum value in a specific range, which would be this range. To apply the minimum function, we'll say equals min, like that, min, open your brackets. I'm going to show you two methods. I'll do a different one on the max. Again, you can always, for range, just drag down and select your whole range. Once you're done, you can close your brackets, hit return, and it would show that the minimum value in this range is 53. So as we can see there, 53 is the minimum value. I'll actually show you a third way as well. I'm going to redo min the exact same way, but we'll just type it in. So we'll manually enter our range. So equals min. We want it to start at the range to start at cell C3, so C3. You put a colon, and then the last number in our range would be C12, C12, C12. As you can see, Excel highlights the range for you, close it, and it would still come up with 53. For max, we'll say equals max. Now we can type it in manually, which is a much longer way to do it, but it also works the same, so I'll show you. So we'll click on C3, that would be our first one. Then you'll use semicolon. What is the next number? Next one is C4, semicolon, C5, and so on. So even though it highlights the exact same range for us, because we're doing it individually, Excel creates a different color for individual cells. And we'll close it. And as you can see, the maximum value in this range is 94. Let's do it the quick way. Equals max, open bracket, drag down the range, close brackets, and it is 94. Now an even quicker way, if we're going to do a whole lot of calculations based on a specific range, we'll select the range, we'll just call it score in the name box above. Now we've named this range, so let's do this equals max score, and it would give you the same thing. So going forward with the rest of them, I'll just use the shortcut score for the range to calculate. Now what this refers to is basically the largest number, which should also give you the max number if you use first. So the first largest number, the second largest, third largest, and so on. Same with smallest. First smallest should also give you the minimum value, and the first largest should also give you the maximum value. So to do this, even though I've typed largest here, the function is equals large, not largest, just large. Open, and we want to look in score. Apologies, I shouldn't have closed the bracket there. So now we need to give it the value. What are we looking for? First, second, third, whatever it is. So we'll say 1. Close the bracket and return. So the the first largest number is the same as max, which is 94. Let's do the next one. Large, score, second largest number, 90. So as we can see here, 90 seems to be the second largest number. The third largest number seems to be 83, but let's use the function to calculate that for us. Large, score 3, 83. Large, score. I just want to stop there. As you can see, Excel helps you complete your function or formula. So with the large function, it would tell you that it needs an array, which is a range, and then to go on to the next condition in the specific function, it asks for a semicolon. So not a comma and not a colon. It has to be a semicolon. So as soon as I hit semicolon, now it moves on to the next argument in this function for the criteria for it to work. So this would be 4, and it calculates 83 as the fourth largest number as well, because there's 83 twice. So if we have to change this one to 81, for instance, then 81 would be the fourth largest. Then the fifth largest would be large, score, semicolon, 5, close brackets, hit return. Fifth largest is 71. Now to do smallest, I'm going to do it in an even quicker way. So we'll say equals small, open your brackets, our range is score, and instead of now typing in 1, 2, 3, 4, I'm just going to simply select E7, which is the range, because this allows us to copy the formula down. And we'll close the brackets. Now we can simply, we'll see again, smallest, first smallest is the minimum value, which is 53. Now we can simply drag this formula down, and it would automatically take each one of these as the next row, because it steps it down by 1. If you drag it to the side, it would step the columns up by 1. But because we're dragging it down, it goes 7, 8, 9, 10, 11. Again, 69 appears twice. So let's change this one to 65, which means the fourth smallest number would be 65. And there's 10 here, and there's 5 and 5, so this basically covers the whole class scores. Largest is 94, 90, 83, 81, 71, and then 69, 65, 60, 59, and 53 being the smallest. And that concludes this lesson on the min, max, large, and small functions. Thank you, and I will see you in the next lesson. In this lesson, I will show you how to use the MINIFS and the MAXIFS functions. So I've added another column to our table from the previous lesson, where I've put the gender of the specific student in as well. So we will find out what the maximum score was from a female student, the minimum score by a female student, and the same with male students. So let's start with the maximum based on specific criteria. To do this, we will use the function MAXIFS. So it will be equals MAXIFS. Open your brackets. What is the range? So this would be the score range, the result that you want to appear here. So our score range would be this, or score. As you can see, it automatically makes it score because then we'll use our semicolon to move on to the next argument in the function. So criteria range 1. You can apply multiple criteria here. Same with the SUMIFS function. With the MAXIFS function, you can also create a whole lot of different criteria, but we will just create one for the purpose of this lesson. So the criteria range would be the female or male range, and we want to find female only. Again, you have to put it in apostrophes, otherwise Excel will not find the correct value there. Once we're done, we close our brackets, hit return, and it shows here that 94. So if we go through here, female students, yes, 94 is the maximum score achieved by a female student. Let's do the same with the males. MAXIFS, open brackets, range is that one. The criteria range would be this one, or we can simply say C3 colon C12 would be the end of the range, C12, and it highlights the range for you. What is the criteria? Male. Close brackets, maximum score achieved by a male student is 90, which is this one here. Now let's do exactly the same with minimum scores. Again, where this is MAXIFS, the min will just be MINIFS. Range is the same, criteria is the same, criteria range, apologies, and female. Close the brackets. Let's just do this one, FS, range, criteria range, male. Okay, so let's see, female students, minimum would be a 60, male students, minimum would be 53. And that is how you can use the MAXIFS and MINIFS functions to calculate maximum and minimum values based on specific criteria. Thank you, and I will see you in the next lesson. In this lesson, I will show you how to use the MODE or MODE function to return the most commonly occurring number in a specific range. So basically it would take the range and see which number appears the most. In this case it would be number 3, but we'll do the calculations. Now I've created two columns here because the MODE function like this, MODE, is a function used in older versions of Excel, like Excel 2007. So it's been replaced by the MODE.SNGL or single function. They both perform the exact same function, but as you can see here, the MODE function is available for compatibility with Excel 2007 and earlier. So basically Excel books that has .xls at the end and not .xlsx. Apologies, I had to think there. So we'll do the MODE function, and then I'll just do the MODE.SNGL function to show you that that is the one that newer versions of Excel use to perform the same function. So what we'll do is we'll type equals MODE, open your brackets, select your range, simple like that, close your brackets, and it would show you that the number 3 is the most commonly occurring number in this range. Let's do the same thing with the mode.SNGL function. Open the bracket, select the range, close the bracket, and it shows you the number 3. Let's do the next one. What I'm going to do, I'm going to actually just copy the formula down and copy this formula down. As you can see, it keeps showing the same result. It shows that 41 that appears 3 times is the most common number here. 15 appears 3 times, and the same on this side. Now, what will the function do if it cannot find one? So each number appears once here. So let's quickly see what happens if we do this. So as you can see, it shows you an error. So it shows that the value is not available. The purpose of the function is to give a specific value. In this case, it cannot give a value, and that's why you would get the value not available error. It would do the exact same thing with mode.SNGL. And there you go. Now let's just true, true, false, false, not, and true. Let's quickly see what happens if we use these functions on text. As you can see, it shows you again not applicable, because the mode or mode.SNGL functions are made for numbers and not for text. So it's not going to show you that true is the most commonly occurring value, because it specifically looks for values which is numbers only. That also means that if it's numbers, you can use it with currency, you can use it with dates, you can use it with percentage or time, anything in Excel that is seen as a number format. And that concludes this lesson. I will see you in the next lesson. In this lesson, I will show you how to use functions to rank a specific list of numbers from 1 to how many ever numbers are in the list, so from biggest to smallest, or from smallest to bigger. So you can do it descending, which means largest first, smallest last, or ascending, which would be smallest to largest. So the original formula function to use would be the rank function. Again, this is a function that is used for Microsoft Excel 2007. The newer versions of Excel, the function is the RANK.EQ function. So basically, if you have a 2007 Excel version, this function would not exist in that version. You will have only the rank, but I'll show you both, and again they will, like the mode and the mode.SNGL functions, they will produce the same values. So let's quickly do this function. So basically we've got countries and their populations, and we want to see how they are ranked according to this list. So we'll say equals rank, and I'm going to go down there, and as you can see, again, this one says this function is available for compatibility with Excel 2007 and earlier, but it will still work. So we'll say rank, the number, which number, what are we looking for? We're looking for that number. This is literally just data, and it has nothing to do with the function. The function only worries about the numbers. The ref would be your range that you want to use. So in this case, that range there. And then you have another one. If we were to close this off now, it would automatically do it as descending, so from highest to smallest, meaning the higher numbers will be ranked as a lower value. So basically the highest number would be 1, the second highest number would be 2, and so on. But we'll do the full formula. So then you choose 0 for descending, 1 for ascending. So we will choose 0 because we want to see which one is the highest. Close your brackets, hit return, and it shows you that this is the third highest number. So out of these countries, the USA has the third largest population. Let's simply drag all of these down just to copy the formula. And as you can see, I made an error here because I did not lock the range. So basically if I pull this down, it would take the range down one as well. So now it's reading that range there and not from there. My error, apologies for that. 2 ways to lock the range. Simply put little dollar signs in front of the column reference and the row reference on both ends, but not your number, because your number needs to go down. Okay, but I obviously need to do it on this one here. And if we draw it down now, it would work out correctly. Or we simply call our range population by selecting it, name box. Now our range is called population, so we can just say equals rank. This number, our reference is population, and the order is 0. Now it would automatically lock it on population. So what does this function tell us? It tells us that China is ranked number 1 population, India number 2, USA number 3, and so on. These are actually correct values from June 2022. Let's use the RANK.EQ function to perform the exact same function or calculation, although this is for the newer versions of Excel. So rank.EQ. Also, it doesn't matter if you type your function in small letters or in capital letters. That doesn't have an effect on anything, so you can type it as that in capitals or in smalls. RANK.EQ, it would do the exact same thing. So our number is the population, our reference is that. It would automatically take population now, and our order is 0. I'm just going to simply double click now, so it would autofill the series, and you can see it does exactly the same. Now let's reverse. So we want to see where in these 10 countries does the USA lie from smallest to largest. So smallest number should be number 1 and largest should be number 10. So basically Mexico and China would swap and so on. Okay, rank.EQ, open your bracket, your reference, your number that you want to rank. Your reference is population, and the order is now 1 because we're going ascending. So USA is now 8th smallest out of this range. The population value is 8th smallest out of this range. Obviously not in the world, but out of these 10. And let's drag it down, and as you can see, China is ranked 1st in largest, but 10th if you reverse it for smallest, and this one is the opposite way around. So that concludes this lesson on how to use the rank or the newer version, the rank.EQ functions, to figure out where a specific number is ranked, whether it's descending or ascending in a specific range of numbers. Thank you. I will see you in the next lesson. In this lesson, I will show you some functions you can use to generate random values. We've got the rand function, the RANDBETWEEN function, and another one called RANDARRAY, but we'll get to that one when we're done with these two. Both of them will generate random numbers on the fly, if you will. The rand function creates decimal numbers between 0 and 1, so it would basically be 0 point and then however many decimal numbers you want the random number to be. I'll show you how to add and remove decimals, and then RANDBETWEEN will give you integers or full numbers, so not decimals that has a comma, just solid numbers between the values that you tell it. So let's start with the rand function. We'll say equals RAND, you open bracket, close bracket, and function is done. Hit enter, and as you can see, just gives us a random number. Now these functions do update themselves after every completion of another function. So if we were to say rand again here, once we hit return, that number is going to change again. So every time you perform a function, they will change. If, for instance, you like this specific number here, you want to keep it, you can always say copy it and paste the value. As you can see there, the value. Paste the value only. So this one has updated itself again, but you've secured that one. Okay, so I'm just going to drag them down. We can keep doing it over and over, and they will keep updating themselves. So random values. RANDBETWEEN would be perfect if we want to create, let's say we want, so we'll start the function with equals RANDBETWEEN, open brackets. What is the lowest number? We want numbers between 1000 and 2000. So bottom, semicolon, top, close bracket, hit return. And that's a number between 1000 and 2000. And let's drag them all down. That one's updated itself, but as I said, they keep updating themselves. But they will always provide a value between 1000 and 2000. Let's say we want RANDBETWEEN, we want between 100 and 142. And it would give a value. Only reason why Excel would give an information here is because this specific function differs from the rest of the range. You can simply just ignore it and it would go away. Now let's say we want to make a table with random numbers in that goes across the columns and down the rows. We will use the RANDARRAY to do that. Let me show you how to do that. So it's equals RANDARRAY, like that. You can always check your spelling in the new versions of Excel to make sure. If you were to make a mistake anywhere during that, just so we use it with 1, it would go away. So then you know that something's wrong. The function would always follow you as you go through it. So RANDARRAY, open our brackets. As you can see, it asks us now to start with this function. So we want 10 rows, we want 10 columns, we want our minimum or lowest number to be 100, and we want our maximum number to be 500, and then the last option here, if you were to type false, it would give you decimal numbers, not like this. it would give you a number between 100, so the lowest, absolute lowest would be 100,000, the absolute highest would be 500,000, but it would give you values in between. So for instance, 243.15 would be a value that might be given. So let's start with decimals first. False, close your bracket, and there we go. It gives you 10 rows, 10 columns of random numbers between 100 and 500. Let's say we want to make the decimals less. We only want 2 decimals. This is how you would do it. Same here. We want to make the decimals more, and it will keep going until the limits of Excel, or we want to make it less. Okay, so let's remove this. Now let's say rand array, 10 rows, 10 columns. It didn't have to. I could have just replaced the false with true here, but I want to retype the function so you can see it again. Minimum value of 100, maximum value of 500, and do we want, basically it's asking us, is it an integer? True, yes it is. False, no, we want a decimal. So in this case, true. We wanted integers, so no comma with numbers following. Hit return. And as you can see, there are no decimal spaces. The reason why it's put 0, 0, zeros is because I increased the decimals, but there is just normal full numbers without any decimals. And that is how you can use these random functions to generate random values for whatever purpose you might need them. Thank you, and I will see you in the next lesson. In this lesson, I will show you how you can use functions to round numbers either up or down, or using the normal rules of math, or to round it to an integer. Let me explain. The round function will basically just round to the amount of decimal spaces that you ask it to. The round up would force it up, so even if it's a number lower than 5, that would automatically round down using the round function. Round up will force it to round up, and round down will force it to round down. The int function or integer function would basically just discard all the decimals. So in this case, the 0.2246 would be discarded, and it would just leave the 14. In this case, the 0.579, even a 5 would automatically be rounded up. So it will not give you the value 4, it will just give you the value 3. It will just discard all the decimal spaces. Let's start with the round function. Equals round, open brackets. We want this one, and we want to round it to 3 decimal spaces. So basically up to that point there. So because that is a 6, this function would automatically round the 4 up to 5. As you can see there, 14.225. Let's do this one. Equals round, open brackets, select our number, semicolon, number of digits, we just wanted to round it to 1 digit, and that would basically make this 3.6 because it would use the 7 and round it up. Then round up. Basically with this we force it to round up no matter what the value is. So let's say round up, open our brackets. So we'll use semicolon 2 decimals. So it would force the 4 to be rounded up to a 3, even though in the normal rules of math that would not be the way it would work. As you can see there, 14.23. And let's say this one equals round up, open brackets, our number, and we want this to be rounded up to 2 decimals, so it would just round the 9 up, the 7 up to an 8. Round down is just the exact opposite. Round down, open brackets, the number, let's also use 2 decimals, so that would be 14.22, and round down, say 2 decimals on here. Instead of where a normal round would also round it up, because that 9 is a high number higher than 5, we are now forcing it down, so it would round it down to 3.57, as you can see there. And then the int function basically just discards all the decimals. Equals int, open brackets, the number, and that's where the function ends, close brackets. And I'll just copy it down. So as you can see, it just discards all decimals after the integer number. And that is this lesson on rounding values. Thank you, and I will see you in the next lesson. In this lesson, I will show you how you can use the MROUND, the ceiling, and the floor functions. They are also used to round numbers, but the main difference between them and the normal rounding functions we covered in the previous lesson is that you can apply criteria to these so that they round to a specific multiple, whether that multiple is a decimal or an integer. So let me show you how to use these 3 functions. The mRound would basically be a lot like the round, with the added benefit of choosing the multiple to round to. So it would also use standard laws of math, where a specific number would be automatically rounded up, where other numbers would automatically be rounded down. Ceiling does exactly the same thing, but it would round the number up to the next multiple, meaning the ceiling or the roof, and floor would round the number down to your chosen multiple. So let's start with the mRound. We will just say equals mRound. We'll open our brackets. So what I've done here, I've created our numbers and I've created our multiples, but you can also type it in. So let's just say that's our number, and our multiple, we will just select the cell for the multiple. Close your brackets, and there you have it, 17.25. It's rounded it. If I were to change this to a 13, it would still round it up to 17.25. But if I were to change it to 12, it would round it down to 17. Let me just show you. So as you can see where the rules of math apply. Let's do the next one here, but this time we want to round it to the nearest 0.5 as our multiple. Equals mRound, open our brackets, select, and now I'm going to show you that you can also just type it in, 0.5, close your bracket. 22.5 would be the closest 0.5 multiple to our number. If we want to just use the multiple cell, we just redo the function here, number, semicolon, multiple, close bracket, return 22.5. So let me finish these ones and then we'll carry on to the integers. So ceiling, as I said, would round it up. So ceiling is also a function that was used by Excel 2007. The newer version is called ceiling.math, but I'll do both of them. The same with floor. There's a floor and there's a floor.math. They do exactly the same function. So let's just do ceiling itself. So our number and significance in this case is our multiple, 0.25. I'll type this one in. So ceiling should round it up to 17.25 as well, as it takes it up to the next multiple. And then floor, we'll just do normal floor. Our number, semicolon, significance or multiple, close brackets, that would take it down to 17. Now let's use the ceiling.math in this one. So if we look at this, multiples of 0.5, it should take this one up to 23. Let's see. Ceiling.math, we'll use the ceiling.math function here. We've got our number and we've got our multiple. Close our brackets and it takes it up to 23, where floor would take it to 22.5 as well. Well, we'll do the floor.math. Number, our multiple is 0.5, close our brackets, and 22.5. So let's do all three of these, rounding, ceiling, and floor based on a multiple of 50. So now we're using integers. So let's say MROUND 43 multiple of 50. So always open your brackets, put your first argument. Arguments are always separated by semicolons. It's only in older Excel versions that they used commas. In the new Excel, it's always a semicolon. Close your bracket, hit return. And as you can see, this one rounds it to 50 because 43 is closer to 50 than what it is to 0. Let's do ceiling, which would also take it to 50. Ceiling.math, I'll do the ceiling.math, the newer version. Your number, open bracket, choose your number, semicolon, your multiple, close your brackets. That's all you need to do. And floor equals floor.math, open brackets, number, semicolon, multiple, close bracket, done. Takes it to 0. So I used 43 twice so that you can see that this one actually works on multiples of 50. If I were to just copy this formula down now, it would work because our references are correct. It would take 43 to 0 on the normal round because 43 is closer to 0 than what it is to 100. Ceiling would automatically force it up to 100. So let's drag this down and see. And floor would automatically take it to 0. Now let's do some bigger numbers with the same multiple. So if we were to look at this, we want to take it to 100. So let's just concentrate on the first two digits, which would be 62 here. So 62, normal rounding it to the closest 100 would take it to 1500, where the floor should force it down to 1400. But let's do the functions and see what it gives us. MROUND, open brackets, our number, our multiple, close brackets, and 15. Ceiling would do the same in this case. Only real difference is round would just round it to the closest from whatever it is. Ceiling would force it up, floor would force it down. Ceiling.math, open bracket, number, multiple, close bracket, equals floor dot math, open brackets, our number, semicolon, multiple, close bracket, and it's 1400. So let's just take this whole range, drag it down, and then we can go through it. Now it's multiples of 500. So 6749 to round it normally would take it to 6500. I purposely chose this number, so if I move this up just one digit, 6750, the MROUND would take it to 7000. Yes, the 50 is seen as closer to 100 than the 49. So we are almost exactly in the middle. The middle would be 6750, but that would round it up. One less would round it down. And as you can see, the MROUND would always be the same as either one of these because we're using the same multiples. So in this case, rounding it up, in this case, rounding it down, in this case, rounding it up, rounding it down, rounding it up, rounding it down. And that concludes this lesson on the MROUND, the ceiling, and the floor functions. Thank you, and I will see you in the next lesson. In this lesson, I will show you how to use the MOD function, which is to calculate a mod or a modulus from a specific division. So basically what a modulus is, it would be the remainder of the division has been performed. It might sound like something boring, but it might be something useful if you need to calculate a value of doing something every certain amount of times. So we'll get to that in this little bottom table that I've created here. But basically, if we have to divide our numbers here, 11 divided by 6, how many times can 11 be divided by 6, and what is left is what it would calculate. Now I've got a couple of extra things here. I've got the normal function that Excel provides, which is just our mod function. I will do a formula to show you how to calculate a modulus without using the function, and then just the steps of how a modulus is calculated. So let's start with just the function itself. So to perform the mod function, I will just say equals mod, MOD, open our brackets. This is our number, and the divisor, what are we dividing it by, is 6. So that shows you that 11 divided by 6 is mod 5. It means that there is 5 remaining. So let's explain this a bit more. Let me do the next one. Equals mod, open brackets, 19, semicolon, our divisor is 3, we close the bracket, and the remainder of 19 divided by 3 is 1. So what is the full integer solid number that's left, the difference between this and the result of dividing it by that? So let's break it down into steps, and then I'll also show you how to do a formula on it, and then we'll carry on with the rest. Yeah. So first action would be to divide. That's the first step in calculating a modulus. So we'll say equals 11 divide by 6. Simple as that. So that would be a little formula. We're building a formula here, but in 4 steps to get the same answer, and then we'll do it in one formula. So 11 divided by 6 is 1.833333. So basically 11 can be divided by 6 1.83 times, but if we work with full numbers only, it can only be divided by 6 once. And then what is left is what the mod is. Now, in the previous two previous lessons, we had the floor function and we had the int function. You can use either or to get rid of the decimals, because we want to get rid of the decimals. In mod we don't work with decimals. I'll do the floor function on this one, and then I'll do the int function, which is a better function to use in this case if you were to. But I'll do the floor in this one. It would give us the same result. So we'll say equals floor. I'll just do the normal floor one. They both do the same. This is our number, and we want to I'll multiply. We want to take it to a multiple of 1, full number 1. Close our brackets, so it shows us that 1. So basically just discarding all the decimals. Why did I use the floor and not the MROUND or ceiling? Because MROUND would have rounded it to the closest one, which would have been 2, and ceiling would have done the same thing. Now the next step is to multiply. So what we want to do here is first divide, then we remove the decimal numbers, and then we need to multiply 1, or our result here, by our divisor. So let's do this. So we'll say 1, or the cell here, times by our divisor. That gives us 6. Then to get the actual modulus, we need to subtract the answer from our multiplication from our original number. So we'll say equals the number minus the answer from the multiplication, and that gives us a modulus, a mod of 5. Now let's do the next one. Only difference is I'll use the int function here. So we'll say equals our number divided by 3, because that's what we're dividing with. So that gives us 6.3333. Now we want to lose all the decimals, so we'll use the int in this case, which is a bit quicker. Int. What do we want to convert into an integer? There's that one. Close the brackets, and you'll see 6 there. So with the floor, firstly it's more letters to type, and you have to tell it where to round it to the closest one or half or whatever. The int in this case would be better because it just automatically gets rid of all the decimals. Now we need to multiply, like we multiplied here. So we'll use our integer that's left, multiply by our divisor. Right, so that leaves us with, that gives us an answer of 18. So 3 times 6 would give us 18. Our original number was 19. So what is left? Let's see. 19 minus 18 would give us 1, which is our modulus. So that is the steps on how to calculate a modulus. I will leave the formula for now, but we will get to that, and then I'll show you the main difference between formulas and functions. Now let's do the next one. I've just made all the divisors the same. So to do mod here, mod, open bracket, 12, and our divisor is 17. In a case where your number is lower than your divisor, your mod will always still be your original number. As you can see there, it stays 12. I'm going to just drag these ones down. So 1977 divided by 17 gives you a mod 5. 49552 divided by 17 gives you a mod 14. You will also notice that your mod will never be higher or equal to your divisor, because if the answer was the mod was 17, then it could have just been divided one more time, and then there's no purpose of this. Let's do these ones again, the whole step. So we'll say equals 12 divided by 17. Now that gives us 0.705, and this is why our original number would stay the same. Let's carry on here. We'll say int, and we get our number, and it now gives us 0. So we know that if we're going to multiply 17 by 0, it would give us 0 again, but let's do it anyway. 17 times 0, or C6 times J6 gives us 0, and now we subtract our original number from the answer from our multiplication, and that is why it stays the same. So any number lower than your divisor will yield the same mod as your original number. Again, I'm just going to drag these ones down, and as you can see there, your mod comes to 5, your mod comes to 14. So if we were to, mod is something that you might have used somewhere during your educational career. Somewhere in math you would have had to work out mods. Excel makes it a bit easier. We can do it with a couple of cells, or we can do it with a formula that I'm going to show you now, or Excel provides us with certain functions to make everything a lot easier. So basically this little short function performs the same as doing all these steps here, and it would also do the same as doing the formula. Now to do the formula is a little bit trickier, but still quicker than this. So the first thing we need to do, our purpose is to minus our multiplication from our original number. So that would be the main step. We need to work out the, the multiplication answer and minus that from our number. So we're going to start with our number, and we're going to minus. Now we're going to do our formula. So what do we want to minus from our original number? We want to minus the integer that we get as a result of our number divided by our divisor. That concludes that part. So that part there would yield the 1 times by our divisor. As you can see, this is all still in brackets, so everything in brackets would be worked out as one answer. And close our bracket. So let's just check, have we covered everything? We've got our number that we are subtracting from. We've got our integer result, which includes that because there's our divisor, and we've got our multiplication. So different steps, but let's hit enter and see what our answer is. And as you can see there, it's 5. So let's drag that down. And now to copy the formula, we can just say right click. We highlight these cells here, and we say paste formula. And as you can see, 12, 12, 5, 5, 14, 14. So calculating step by step, quicker than working it out with pen and paper and calculator, or even without a calculator, but still more work than using a formula. Formula, quick, but we need to make sure that we do it the right way. We need to make sure our brackets are applied, that the right calculations are done, and therefore a function created by Excel is there for the specific reason of making this and this a lot easier. So let's look at a clock. 12 hours. This is a form of modulus. So basically, we'll see. I'm just going to do the result here and then you will see why I say this is a form of a modulus. Because every 12th time it does something. So we'll have 1 semicolon, our divisor, which is 12, close. Now, like I explained here, every number lower than the divisor will always be the number. As you can see there, 1. So now let me drag all the way down to 12 and leave it there. So 2 will stay 2, 3 will stay 3, etc., etc. Then when we get to 12, it changes it to 0. So this is where every 12th time. So you perform a range, and at the 12th time, when your numbers are equal to each other, it wraps it back to 0 again, and then it would start again. So if you're running in a sequence, specific sequence like we are here, 13 would in fact be 1. 13 on the time, 1300 hours, which is 1 p.m., it's 1. So I'm just going to quickly, let me just show you a quick way to copy a whole lot of formulas together. Just select the one row of, not the whole row, just the cells you want to copy. Copy that, and let's paste the formulas there. Okay, so a whole lot of things here. All of these comes to zeros, but at the end of the day it gives us the exact same modulus, and 12 gives us a modulus of 0. So why is that? Because 12 divided by 12 can be divided by 12 once, and what is left? There's nothing left. So that's why the modulus of a number divided by the same number is 0. Now let's copy this formula down all the way to 24, and as you can see it starts again, 1, 2, 3, all the way. 24 is also equal to 0. So every number that can be divided by a number, in this case every number that can be divided by 12 or is a multiple of 12, let me rather say that, every number that's a multiple of 12 will always yield a 0 as a modulus. If I were to change this to 48, it would be 0. If I were to change it to 96, it would be 0. If I were to change it to 144, it would be 0. Which means if I were to change it to 145, it should be 1, because then it starts the sequence again, as you can see there. So let's use time. I'm going to just, you can also just select the whole range and drag it down like that. Everything there is the same, everything there is the same. Now I'm going to use time, but in this case 24 hours, because we're working on a 24-hour clock. Let's do this in international time. So if we were to divide 48 by 24, our mod would be 0, same as in this case, but that's not what we're trying to calculate. Let's say the time is 3 p.m. or 1500 hours. In this case, 3 p.m., 1500 hours. What would the time be 48 hours from this time? So if we just use normal time functions, we can simply just say 1500 hours plus 48 hours. It would still be 3 o'clock, because 48 is a multiple of 24. If we were to change that to 49 hours, the time should be 4 o'clock or 1600 hours. So let's do the same with mod. So equals mod number divisor. That would only give us the mod of those two, but we add 15 in this case. because that is the current time that we are trying to calculate. What would the time be? And you can see it is 15. So if we were to change 48 hours, so 1500 or 3 o'clock, what would the time be? 49 hours from then. The time would be 1600 or 4 o'clock. If the time was 2 o'clock, it should go up to 3 o'clock. What would the time be? Let's change this to 2 o'clock as well. And I'm just going to remove this one. I will do it here. Okay, so what would the time be if it is 2 o'clock? What would the time be? 791 hours from then, from 2 o'clock. Time would be 1 o'clock. 2500 hours. 791, 1 o'clock. Sorry, it's doing that because there's not enough space here. So the time would be 1 o'clock. So now, why, when I said here that the modulus can never be higher than the divisor, that it gives me a number here? Simply because we added 2. So if we were to remove that 2, the answer would actually be 23, which is the maximum number this modulus could have been. So just my luck that I chose that specific number. Let's just change it to 761 to 1900 or 7 p.m. 761 1900. So that was a little mistake I did not plan, but just to basically show you how it would work if you were to calculate using modulus. And that basically explains what a modulus is, how you step by step calculate a modulus, how you do it with a formula, and how the mod function is used to simplify all of that. Thank you so much, and I will see you in the next lesson. In this lesson, I will show you how you can use the subtotal and the aggregate functions. The purpose of these functions are to perform various different functions within it. The subtotal and aggregate function can both perform a whole lot of different functions on a set of data, but I will show you the main difference between the two. So they basically do the same thing, but when there might be errors in a range, or when you start hiding rows, that is where the aggregate is a more powerful function. So let's just we'll perform the same 4 calculations on this table here, and then I'm going to change some things so that you can see where the aggregate is more flexible. Let's start with subtotal. So we want to count simply how many different fruits we have. So normally we would just use the COUNTA function. So let's say equals subtotal. What function do we want to use? Number 3 is our COUNTA. So that would be COUNTA within the subtotal function. And then what is our range? And that is our range there. Simple as that. To do the aggregate, we just say equals aggregate COUNTA. I'm going to I'll explain that when making some changes here. So basically you can see that they both yield the exact same value. Let's for instance, hide some cells here. So we're going to hide 4 cells here, hide them. Now what we can do with the aggregate, the subtotal still sees the whole range from B3 to B13, even though there were a couple of rows hidden. So let's perform the aggregate function again, but give it a bit more power. So we'll say aggregate, apologies, number 3, that's the count A. And what rules do we want to give here? We want it to ignore hidden rows, or we can say there's a couple of options here. Best one would be just to choose number 3, ignore hidden rows, error values, nested subtotals, and aggregate functions. So our option is number 3, and our range is there. So as you can see, it still says B3 to B13. It doesn't say B3 to B7 and then B12 to B13. It still takes the whole range. So it counts the hidden cells as well. Finish off the aggregate function, close our brackets, and now it only counts 7 because visibly on the screen there are only 7 cells, where the subtotal cannot ignore hidden cells. Now if we were to unhide this again, you'll see the aggregate function goes back. So this is a dynamic function. As you change something here in the data that it works from, it would automatically update itself. I'm going to keep this. No, let's do the next one. Let's do sum. So we'll do subtotal, and we want to do sum, which is number 9, and we want to do for the year 2019. And let's do the same with aggregate. Sum is number 9. We ignore nothing, and the year 2019. As you can see, same value. When I hide something, it would stay the same. If I were to change my option there to ignore the hidden rows, number 3, it would ignore them and only add what you can see on the screen. The nice thing about both of these functions, I'm just going to unhide again. The nice thing about both of these functions, let me just retype it again. Subtotal, we want to sum, and we want to not only add that, but we also want to add sum that, sum that, sum that, and sum that. And there we go. You can add up to 254 different ranges for it to sum. It makes it so much more powerful than any of the other sum functions. Let's do the same with aggregate. Aggregate, open up our brackets, we want to sum. This time we want to ignore all possibilities, and we're working on this, on this, on this, exactly the same. And it's the same thing with the aggregate. I'm going to go back to our range. With the aggregate, instead of selecting like this, we can just select the whole block as well, and it would still give us the same function. But let's keep it the same as our sum function. Now if we were to make this an error message. It would ignore this. Wait, equals 12 divided by 0. Okay, sorry, have to be an actual error. Apologies for that. Oh, sorry, I forgot the divide 0 part. As you can see now, the subtotal cannot calculate anymore because there is an error in here where the aggregate ignores that error and just sums up the rest of it. That is something that the subtotal cannot do. If we were to hide columns here, let's just remove that. You'll see that the subtotal will add everything together, even the hidden ones where the aggregate would ignore them. So basically they both perform the same type of functions. The aggregate just has a little bit more power to the subtotal function. So let's do the same with them as we want to find out what our maximum sale was. Let's choose number 4, which is our maximum sale, and our reference, let's just do 2021, close our brackets. So the maximum best month, or the best seller in 2021 would have been that one, which is our guava. So you would have to use lookup functions with this to present the guava value, but this is just to explain the subtotal and aggregate. And equals aggregate maximum value, ignore everything, 2021 yields the same one. And let's do minimum subtotal. Minimum would be number 5, and our reference is all of these here. Minimum was 14, so that was basically oranges in 2020 was the worst seller. Equals aggregate minimum number 5, ignore all errors, and let's just take the whole block like that, 14498. So let's firstly as you can see, error message, it messes up the subtotal function. Okay, hidden cells, it now shows that the maximum visible value here is 25,359 in 2021, because this is only in 2021, and the minimum stays the same. If I were to hide that, I'll hide those ones as well, but let me just do it quickly. Now the minimum on the screen is 15,323. Let's just unhide all of these, and that is basically how you can use the subtotal and aggregate functions. They do have a lot more power to them. So aggregate has 19 different built-in functions, and the sum function, subtotal function, has 11. It just starts again, 101 would still be the same, but subtotal only has 11 functions. So mostly they can perform the same thing, but depending on what you want to do, the aggregate would be more powerful. You can use it in exactly the same way as the subtotal, where it asks you for the errors, or what to ignore. let's say anything, average. You can choose what you want to ignore, or you can ignore nothing. If you ignore nothing, it would basically be a subtotal function, but with a couple more, with 19 different functions built into it, where subtotal only has 11. So always best to just go for the aggregate and get used to that one. Thank you so much. I will see you in the next lesson. In this lesson, I will show you how you can use the left, mid, right, as well as the len, len or length functions to do some calculations. The left, mid, and right functions are used to extract characters from a specific, they say text, but any string. I've purposely made this a number to show that it works on text and numbers, but these functions are a little bit limited. I'll just show you how you can use them. So what we want to do is extract certain characters from this specific input here. So let's start with the left, then I'll do right, and then mid, as it is a bit more complicated. So to do the left, we'll just say equals left. From where do you want to extract this? You can simply click on your cell containing the text or the input, or you can physically type it in like this, type it in like that, in apostrophes. But we want to extract it from there. How many characters do we want to extract? So we want to extract the first three. So 1, 2, 3. Basically, we want to extract ABC, the first three characters. Those are brackets, and there you have it, ABC. Let's do this one, and we'll extract the first 4. Left, open brackets, that's our text there. Do we want to extract, the first 4. And on this one, left, open up our brackets, select our text, and we want to extract the first 5 characters. Then to do the right, it's basically just opposite of the left, but it counts back from the right. So it goes 1, 2, 3, and 1, 2, 3, 4, and 1, 2, 3, 4, 5, etc. Equals right, right, it. Now text, 3 characters, equals right, our text, 4 characters, and equals right, our text, 5 characters. So you'll see that it puts it in the same order as what it is in your input, but it would just count 5 characters from the right, or how many ever characters you allocate to it from the left or from the right. The mid function is a little bit trickier because you need to tell it where in your range to start and how many characters to count from there. So let's start and just show you how we do it here. Mid, the text, the starting number of characters. So if we were to extract 1, 2, and 3 from here, we need to start at character number 5, because A is 1, B is 2, C is 3, dash is 4, 1 is 5. So we start at character number 5, and we want to extract 3 characters from there, which would give us the 1, 2, 3. And as you can see there, 1, 2, 3. Let me just center this, and I'll just center those are centered. Okay. Mid here, we want to extract 5 and 6 from here. So equals mid, text, click on your cell, semicolon, we start at character number 5, and we want to extract 2 characters, 5 and 6. And then on the last one, these functions have nothing to do with each other, so you can certainly extract anything that's already been extracted by another function here. Equals mid. Our text, we want to start at character 3 and extract 6 characters. So 1, 2, 3, 4, 5, 6. So it leaves the A and B and it leaves the J and K. Quite simple. Now, what happens if, for instance, we want to use this mid one, but we change that to a space? Let's see if it changes anything. As you can see, it doesn't change anything. We change this, it's not even relevant to that, but it doesn't change anything. Why is that? Because characters, spaces are also seen as characters, and I'll show that in the length function. If I were to move 1, 2 spaces up, you'll see it will only extract number 1 because it counted 5 characters. So 1, 2, 3, 4, 5 characters, and it started at that space, 2 spaces, and then the 1. So they see spaces as characters as well. So let's do some lengths here, and then you will see. Let's just type here, hello, my name is Quentin. Now let's work out the length of this string here. It doesn't count specifically letters or words or numbers. It literally counts every single character, spaces, everything. So let's say equals len, open our brackets, text, select your text or type in your text in apostrophes like that. And once you're done, close your brackets. So the string is 25 characters long. If I were to type it without a comma, it should be 24, but let's just see. Hello, my name is Quentin. I'm just going to drag it down because it would automatically take B10 now. And you see 24. If I were to copy that one, but add 1, 2, 1, 2, 1, 2, 1, 2 spaces in between, you'll see that the number also increases. So all these functions extract or count characters, including spaces. Any character in a specific cell would be seen as a character. Anything that makes the information in the cell bigger. And that concludes this lesson on the left, mid, right, and len or length functions. Thank you, and I will see you in the next lesson. In this lesson, I will show you how you can use the find and the search functions to look for something that you wanted to search in a specific text string or in a specific cell, and it would return the position, the character position. So like we did in the previous lesson, characters meaning anything including spaces. So it would return the character position of where that specific word or string or whatever it is you want to search for starts. So they basically perform the exact same function. Only difference is the find function is case sensitive, and if there's something wrong, that you'll see when we carry on through the lesson, it would throw an error out. The search function is a little bit more forgiving, and it doesn't care about case, and if it can sort of match it, it would still do that for you. The only thing is both of these would throw out an error if it cannot find what you are looking for. So if it's not there at all, or it really cannot find it, not even close, it would throw out an error. So let's start by doing the find function. We'll just say equals find. We open our brackets. Find text. What is it that we want to find? We want to find name or the cell. And we'll do semicolon. Where do we want to find it? We want to find it in this string here. And starting number. I will show you what the starting number does. It is not necessary to put the starting number in. You can simply say starting number 1, which means it will start searching from character number 1. Or we can leave it blank like that. Close your brackets, hit return, and it says that name, the word name in this string, is character number 10. So let's check this. What we'll do is we'll just hold our shift in and start counting by highlighting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As you can see, the N in name, the first letter, starts at character number 10 in the string here. Let's include the starting number. Anything up to number 10. So whether we make it 10, 9, 4, doesn't matter. It doesn't change the result as long as it's up to the first character of what you're looking for or before that. It would still search from the start of the string, so that doesn't mean it's going to search from character number 4. It still searches from the start. If I were to make this 11, it would show me an error because it would start searching from the A going that way. Then it can't find name because we've passed the N already. So that is the purpose of this last condition in the function, which is not required unless you want to perform that function. Let's go on to search. Equals search, same thing, just 2 characters more to type, but more powerful. So we want to find the word name within this text here and close our brackets, and it starts at position character number 10. Now let's do this one. So we can simply, because we are using cell references, we can simply just copy it down. It would show an error. Why does it show an error? Let's see what search does. Search does not show an error. It shows that Udemy, the U, first letter, first character, starts at position 23, character 23. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So why did find not find it? It's because the Udemy that I've typed here does not have a capital U. So this is the main difference. This one is not as sensitive as find, so it can see Udemy. It's the same thing more or less. If we were to fix this and make it a capital U, find would also find it, but we'll leave it as it is. Then let's see the BEA, only part of the word with a little dash there. If we were to, a little asterisk, sorry. If we were to remove the asterisk, find will find it because it's looking for characters. It doesn't need to be a complete word. It only looks for characters. It will again produce an error value because of that little asterisk that's there. But let's do the form function and see. Equals find. We want to find that cell, the text in that cell, in the string or the cell. And as you can see, error where the search still finds it because it can see the BEA. There are more correct characters than error characters. Let's just quickly count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the last one equals find. We want to find the word Udemy in this text sentence here. Again, find will not find it. Will search find it. Let's just type it out again. Search, open brackets, Udemy in the cell. So as you can see now, even though search is more powerful than find, if you're asking it to search for character position of a text string or word in another text string that has nothing to do with it at all, it will also turn up an error. And that is how you can use the find and search functions. Thank you so much, and I will see you in the next lesson. In this lesson, I will teach you how you can use the replace and the substitute functions. They can both perform the same function, but the substitute is a little bit better and more powerful, as you can tell it what to substitute with your new character, whereas the replace, you'll need to tell it where to start, how many characters to count from there, and what to replace it with. So let's just get into this so you can understand what I mean there. So what we want to do here, we want to remove the 1, 2, 3 so that it only gives us the value blue. So we want to basically replace it with nothing, or an empty string as it's known in Excel. So to do this, we'll say equals replace, like that. Open your brackets, our text, alt text, starting number. So which character do we want to start at? So it would be number 1, 2, 3, 4, 5. We want to start at character number 5. It needs to count how many characters from there. 1, 2, 3 characters from there. So we'll put 3. And what do we want to replace it with? We want to replace it with an empty string. An empty string is basically just apostrophe, apostrophe like that, or double apostrophe like that. Close your brackets, and as you can see, it is now removed. The 1, 2, 3 is removed. You can also replace it with whatever you want. You can replace it with 1, 2, 3, 4. It basically just finds characters, or it goes to a character number where it is in your specific string. It adds characters, counts, selects that range, and replaces it with what you tell it to be replaced with. Let's remove the 3 asterisks in front of brown. So equals replace, open our brackets, our text, you click on your text there, semicolon, starting at character number 1, semicolon, 3 characters, and we also want to replace this with just an empty string. And as you can see there, it says brown. If we were to, let's go back to where we are at the characters. So 3 characters. If we were to say light brown, for instance, we will just tell it to put there in text though. So you need to open your apostrophes, light, space, and it would make it light brown. If we were to replace that in the middle of a word, the little hash in the middle of the word, equals replace, open our brackets, select our text, semicolon to go on to the next criteria. 1, 2, 3, character number 3, and we only want to replace one character with an empty string. And there we go. Now there's a spelling error here. We want to replace that A with an E to spell green with a double E. So again, equals replace, open bracket, select your text. You can also type in the text here. Let's do it like this. Starting at number 1, 2, 3, 4, semicolon, one character, and replace that specific character with the letter E. And there we go, green. Or just highlight that part, green. Now let's move on to the substitute function. So this one you have to give it a character position, tell it how many characters to count and what to replace with. The substitute works a little bit different, but is a little bit more powerful than the replace one. So let's see. We'll say equals substitute, like that. In the new versions of Excel, as soon as you make an error with typing, this little pop-up helper here would go away. Then you know that something was typed wrong somewhere. Substitute, open brackets. In the replace, it asked old text. In substitute, it just says text, and I'll explain what this means. So the text would be your input, your whole text string. Then old text, meaning what from this do you want to substitute or replace? What do you want to remove here and put something else in its place? So in this case, we want to remove open apostrophes because we're telling it text to remove. We want to remove 1, 2, 3. Close your apostrophes, semicolon. What do you want to replace it with? We want to replace it with an empty string like that. The new text is an empty string. Close your brackets, and it's removed it. So that's what a substitute function would look like. That is what a replace function would look like. This one is easier. You don't have to go and count. You can physically and visibly just see what you want to remove and tell Excel what to remove. Let's remove that one little asterisk there. Equals substitute, open brackets. From there, we want to find that, and we want to semicolon remove it with an empty string. Now, as you can see, there's another part to this function. I will show you on this last function, on this last text, what you can use that for, because it doesn't apply to this. That's why I've just closed my brackets. So I will get there. This one we want to replace the A again. So equals substitute, open your brackets, select your text. What from the old text do you want to replace? We want to replace that A there, and we want to replace it with an E. And then the last one, we want to remove all these hashtags here. So as you can see, in this instance, the replace function would not work because you need to give it a character position and tell it how many to count. So in this case, it would just remove the whole word. It would start there and end there. This is where substitute is a little bit more powerful. So let's do this. Substitute, open your brackets, select the text or type in the text, semicolon. What is it that we want to replace? We want to replace the hashtags, and we want to replace it with an empty string. Now I'm going to come back to the instance number. What the substitute would do is find all the characters that you tell it to replace, and replace all of them with what you tell it to replace it with. In this case, finding all the hashtags and replacing all of them with an empty string. So it would return red. Let's redo this whole function, but only remove that middle one there. Our alt text, what is it from our alt text that we want to substitute? We want to substitute the hash. We want to replace it with an empty string, but which one? It basically asks you which one. So you need to tell it which one. So it would be the fourth one. 1, 2, 3, 4. The fourth one is what we want to replace. Only the fourth one. And now it's taken that one out but left the rest. If we were to say the first one, it would take away the first one there. How many are there? There's 7 in total. If we were to say the seventh one, the first, second, and third would yield the same value, because there would just be 2 left. So just to show you, second would make it the same. The seventh one would take away 1 from the end. The sixth one would take away that one, but it would still yield the same value. If we were to say take away the 8th one, it would just return our same text, because there are not 8 instances. So the 8th one doesn't exist basically. So it would replace nothing, as you can see there. But in this case, we just wanted to replace the 4th one in the middle and just leave us with 3, our word, and another 3. And that is how you can use the replace and substitute functions to basically replace characters by other characters of your choice. Thank you, and I will see you in the next lesson. In this lesson, I will show you how you can use the clean and trim functions to clean up or make a string of text look a little bit better. So the purpose of the clean function would be to remove any line breaks, and the trim function would be to neaten it up a little bit. So for now, I'm not going to apply the clean function to this first one, because there are no line breaks. It doesn't do anything to spaces. So let me do the clean on this one here. You know what? While I'm doing this, I never put some borders in there. Apologies for that. Let me do on the cell here. So we basically want to remove a line break here. Now, the only reason why there is a line break is because it went over to the next line due to the text being wrapped. So there's not an actual line break by the enter button, but rather spaces here. And that is just to show you what the trim would do to it. So let's start with clean. So we'll say equals clean, open our brackets. What is your text? That's simple as that. Close your brackets. And as you can see, it forces it into one line. So it removes the wording from the bottom line. It doesn't correct the sentence at all, just removes that line break. Let's do the same with this one. Now with this one, there is an actual line break where I made line spaces in between them. So it's not just spaces that's wrapped. As you can see, the text is wrapped here. It's actual line breaks. Let me show you what the clean does to one like the string like this. Clean, open bracket, text, close bracket, return. So what it would do is just take this word starting at the line break and move it, or this character, the first character after the line break, and move it right next to the last character before the line breaks. Unfortunately, the trim function would do exactly the same as that because there is no space for it to read in between those two characters. But let's see, I'm just apply the clean function on this one as well. B3, I just typed in the cell reference. Like you can see, it does nothing to the specific string of text. But what would the trim function do? Trim this text here. So the trim function makes it look more like a sentence. It removes all the extra spaces and makes it look a bit more like an acceptable sentence. Trim function on this one. So as you can see, because this is a whole lot of spaces in between, it removes all the extra spaces so that there's only one space between the words. On this one, it would give us the same error with the A and the B. Sorry, with the A and the B, unfortunately. But let me show you what it does. So as you can see, it removes the line breaks and it removes the spaces. It pushes it to the left, makes it a sentence, but because there is no space, if I were to put a space after the A there, it would yield the correct value. Even the clean made a space there because clean ignores spaces, but the trim would actually yield the correct value that we want by putting a space after the last character before line breaks. Thank you so much. I will see you in the next lesson. In this lesson, I will show you how to use the CONCAT, which is a concatenate function, and the text join function. What these two functions basically do is take text from a range of different cells or text that you tell it. You can actually type the text in as well, and it puts it into one cell. The main difference between these two are that the concat one would basically take this whole value and just push it next to each other in one long string, where the text join, you can actually allocate a delimiter that you want to put between each one of the values. This is a new function that's only available in the new versions of Excel. The previous one in the older versions, if you don't have this one, would be called concatenate, like that. It basically does what this one does, but it's an older version function. In this one, we'll just cover this. The specific one, concat, C-O-N-C-A-T, it does exactly the same. So let's start with the concat. You'll say concat, like that, open, highlight your text, and close your brackets. So text just the whole range, and hit return. So as you can see, it took 726498 and it just pushed it together as one. If we were to do it another way by actually typing our text, 7 2, 6, 4, 9, 8. Oops. So as you can see, between every text you put a semicolon, and your text must be in apostrophes. It does exactly the same thing. You can also give it 2 ranges or even more to join. Concat open. So text 1 basically would be this whole range, and text 2 would be this whole range. And as you can see, if we were to swap it around, I'm just gonna edit the function like that. Make that text 1 and that text 2. It would start with this one and then go to that one, but it just pushes them all together. So let's just fix this back to the way it was, and we'll do the same here. Concat. Okay, so now let's do text join. I just made it a bit bigger because I could see that it's not going to fit in here. So equals text join. Okay, so what do we want our delimiter to be? We just want it to be simple comma. Okay. Ignore empty cells. True. That would play a part when we get here. And our text like that. And as you can see, this one puts 726498. And let's do the same on this one. Text join. If you do not want a delimiter, you can use the text join as doing the exact function as the concat. Your delimiter will then just be an empty string like that. But we just want it to be a comma in this case. Ignore empty text, true, and our text string is that. Perfect. Same with this one. We can add a second text string. Okay, so it would basically just carry on like this. What we can also do, I'm going to retype it, text join. If we want our delimiter to be comma space, you literally just type in comma and a space. And we ignore empty text. This is our text, close your brackets. And as you can see now, it puts a space after every value from your range here. And that is how you use the concat and text join functions. Thank you so much. I'll see you in the next lesson. In this lesson, I will teach you how you can use the upper, lower, and proper functions to change text strings to uppercase to lowercase, and proper, which would be starting with capital letter or uppercase and then lowercase after that for each word. So these are actually very simple and easy functions. To do uppercase, we'll say equals upper, open our brackets, select the cell with your text or simply type your text. Remember, when you type text, always type it in apostrophes and close it again. And you can type it any which way because it would automatically make everything uppercase. So select our text and it makes it capital letters. upper or uppercase in this case. Select text, close bracket, equals upper, open brackets, select text, close brackets, equals upper, open text, select, open brackets, select text. Lowercase would just do the reverse of this one, equals lower like that, and our text is here. I will copy this value down because it just has to take the next one but in the same column. And then proper, let me show you what proper does. Proper, open brackets, select your cell with the text. As you can see, first word and second word would now start with a capital letter. Copy that one down by simply double clicking. It would just fill the series with the formula or with the function, and that is the proper way. So uppercase, lowercase, and proper. Thank you so much. I will see you in the next lesson, which would be our last standard lesson for this course, and then there will be a bonus lesson after that before you receive your certificate. In this lesson, I will show you how you can use the text function. The purpose of the text function is to apply number formatting to numbers. So basically anything that is seen as a number, just a normal string of numbers, currencies, accounting, numbers with decimals, percentage, dates, times, anything that Excel sees as a number. This might sound simple because why can't you just go and change it to currency here if you want to, because it has a bit of extra features that I'll show you during the lesson. So what we want to do, we want to change this to currency, and I'll show you a couple of different ways to do it. To start with that, we'll just say equals text. We open our brackets, we select our input or the value that we want to change, and how do we want to format it. Now this is very important that you do exactly what I'm going to show you to do here. You have to always, when you're doing a text formatting, the format text part, you always have to open up with your apostrophes. Then you tell the function what it needs to perform. So we want to put a currency sign of dollar in front of it, and we want our number. We can just put some zeros like that. 3 is fine, and that's what we want. So let's see, and just close our brackets. Let's see how it does it. So as you can see, it's now put a dollar in front, dollar sign in front of it. Now we're not happy with the layout of this, so let's change it. I'm just simply going to click on that part of the function and change it here. We want a space between the dollar sign and our value. So we just put a space in between it. But we're not happy with this as well. We want it to be a decent way of putting a value where there's a space between thousands as well. So you'll put your currency sign or whatever. You can put any sign you want here. It will literally just print that out. So you can even put the letter T if you want. Currency sign, space, and then follow the format as if it was every 1,000 would get a space in between. Hit return, and as you can see, that's how it does it now. But now we want to add something on here. We also want to add our decimals on. Apologies, the mistake I made there was that I used a full stop and not a comma. So learn from my mistake, don't use a full stop, use a comma to display it correctly like that. The next thing we want to do on this 1 to 3 is add something in front of it, like just 000. So we'll say equals text. We'll use the value, our number value. It has to be a number value. And how do we want this? Open our apostrophes. We want it 0, 0, 0, 0, 0, 0. So what is this going to do now? Close apostrophes, close our brackets. So the first 3 zeros represents us, our value. We've got 3 zeros. Because we are putting something longer than our string here, it will place these first 3 characters in front of ours. So it would be 0, 0, 0 and then our value. Okay, if I was to change this to 1, 2, 3, 4, this would be 0, 0, 1, 2, 3, 4. Let's see what it does there. If you want to put it as 1, 2, 3 and then the 3 zeros representing our number, it would be 1, 2, 3, 1, 2, 3. Okay, so that is how you simply represent your own number. The number of zeros you put down would be yours, and then anything before that would be placed before that. You cannot place it after it because it would take the last 3 as yours. And then percentage. So let's say we want to say save 20%. So this one we'll have to do a little bit different. We need to create a text string. So we'll say equals. We create our text string. We'll type the word save and space. Always important to put a space. Then you close your text string off. So that would be how it starts, because it needs to say save and then it needs to say 20%. Then space, the and symbol, space again, then you start writing your formula. Text, open your bracket. What is our value? 20%. How do we want to format it? Again, formatting text must be in the apostrophes. We want it to be formatted, you can just put 0, 1, 0 to represent your value, because we're not adding anything to it, and we want it in percentage format. Close your apostrophes, close your brackets. So equals starts your formula, or your formula. This is the text string that you want to place before. You've put a space there. If you don't put a space there, the 20% and save would just be pushed against each other. And means what are you adding to your text string? So you're putting save and you're putting text of that in percentage format. Enter or return. Save 20%. Now the next one, we've got a date format here. So you can see it's a date format. We want to say that the sale ends on 22nd October. So sale ends 22nd October, but I want to change it up. I don't want it to be like this, 22-OCT-22. 2023, apologies. I wanted to type out the whole word, 22 October 2023. So to do that, we'll start it exactly the same as the previous one. We'll say sale ends on space. Close off your text string, space, and sign, space, text, open bracket. Our value is our date here. And what is our date format going to be? So again, always apostrophes. We want this to be long date format. So long date format, we'll put DD, which would represent the day. We want a space after that. Then we want month. So we need to put more than 3. We want a space after that. And we want year. 4 digits to display the full year. We close off our text string and we close off our formula, and we simply hit return. Sale ends, apologies, sale ends on 22nd October 2023. And that is how you can use the text function to convert numbers into text strings with specific formatting applied to them. Now, important thing, this is a text, it is not a number. If I were to create a formula here, I want to say that times 2, it will not work because it is not a number anymore. The function converted it to a text string. This is not a number and this is not a number anymore. Okay guys, that concludes this lesson and also concludes this course. I do have a bonus lesson for you in the next lesson where I'm going to show you quite a complicated formula using a number of functions to perform a specific calculation. Thank you so much